Just showing stuff. So here we go, going live.
We're living on a disk, floating through space, with a tiny sun.
Hey, I'm FTFE. Welcome back to the channel that does to stupidity what Xbox just did to Microsoft. A lot of you probably won't care about this, but for us gamers, this is a really big thing. Microsoft just bought Activision Blizzard, just like threw money at them, $69 billion, and that's literally the biggest thing in entertainment history. The Disney Fox merger was $65 billion. That means that Microsoft now own Call of Duty, Spyro, Diablo, Overwatch, Crash Bandicoot, Candy Crush, like all the big gaming stuff that isn't Ubisoft is now owned by Microsoft. So yeah, PlayStation must be feeling a bit shitty right now. I'm sorry, I'm geeking out. That it's kind of very exciting news because I like Xbox. But hey, anyway, we're here for a Flat Earth debate. Yes, we are. Welcome everybody. I hope you're all doing well. Tonight we have on the channel Hillside, who you would have seen maybe on MC Toon's channel about a week ago. Hillside, hello, welcome to the channel. How you doing?
Doing well, man. Thanks for having me on.
No worries. Thank you for joining. How do you think the debate on MC Toons went?
I mean, probably not that great. I mean, I really wasn't that prepared. Like I said, I don't really have a lot of time to research this, but from like what I've seen and like what I can see in my own city, I mean, it lines up, man. And I don't know, I'm the type, I don't really trust the government and like what they say, because I mean, they lie. I mean, most people will agree to that, but when it comes to this, I don't know, it doesn't seem like everyone's on the same page.
Okay, fair enough. Right, anyway, so why don't you just take a couple of minutes, introduce yourself to my audience, and let people know briefly what's drawn you to the conclusion of the Earth being flat. So I'll just give you a couple of minutes. Off you go.
Okay, yeah, my name's Lucas. I'm a carpenter. I live in Atlanta, and I kind of fell into the flat Earth rabbit hole just on YouTube. I just kept getting recommended for some reason, and at first I saw like the Flat Earth Society and like the Earth is rising and stuff like that, and I just threw it out the window and went about my day. And then I came across David Weiss on TikTok, and he just was presenting some stuff that made sense. And in Atlanta, like when my daughter was born, I was at Kennestone Hospital, and we're like on the second floor, and I can see Stone Mountain, like all of it, from the bottom to the top, from like 40, almost 50 miles away. So I started scratching my head, and I've just been looking into it ever since, and just find the topic fascinating. So here I am.
Okay, and what would it take for you to believe the Earth is not flat?
I mean, there's some compelling arguments on both sides, but the one that does it for me is, I mean, the distances that we're seeing. I mean, with infrared and just the videos that I've seen. I mean, I guess anyone could say they've all been conned, but whenever I can see all of Stone Mountain from 50 miles away, that, kind of does it for me. And the only other, opposing argument is refraction. Well, then that
Which
just
is
kind
a
of
good
seems like
argument.
an afterthought after the observation to support, the spherical model. So
Well,
we can see too far, is my opinion.
I mean, refraction is, the answer. It's amazing that gets denied so much. But you said something about dearth there, David Weiss. David Weiss says that he'd talk to anyone about flat Earth constantly. I'll let anyone on to talk. I'll debate anybody. But why is it, do you think, that he's afraid to debate anyone on this side who actually does debates, like me or MC Toon or Conspiracy Cats or Mr. Sensible? Because we've all asked him, and we've all got blocked.
I don't really want to speak and misspeak on his reasoning as to why he won't debate. From the content that I see from him, I don't really feel like that's the position he wants to hold, is debating. I think he's just more about getting information out and people decide for themselves. But yeah, I mean, I
It's a
am
bit
curious
strange.
as to why. Yeah, I am curious of why he won't come on. But.
Same with all of the big flat earthers, really. Jeranism, Eric Dubay, Mark Sargent. They all refuse to come and talk to us because they know they'll get destroyed. Right. Anyway, I would just love to hear the evidence that you have. So why don't you just take a few minutes, as long as you need, and give me what you would say is the strongest evidence, with as much specifics as you can, so that we can get into what has drawn you to this. What I'm going to tell you is a very, very wrong conclusion.
Okay, can I share my screen?
Yeah, sure. I'll put that up.
Okay. So this is obviously high altitude balloon footage. Can you guys see my screen?
Yeah, sorry, give me 1 second. I'll just put that up for everybody. Yes, lovely. Yeah, so this is high altitude balloon footage, and
yeah, and this is just from David's channel. Anyone can go watch it. But I mean, just seeing footage like this, and then we all know what wide angle lenses do to whatever you're filming. It tries to distort it and scrunch it all in so you get more of a shot or more in your shot. So
that's
can you explain to me why we're seeing a level horizon in this video?
Well, I'm actually seeing a concave horizon. It seems to be going up at the edges. Do you know what camera this is? Does it say?
No, I have no idea.
Check the description. Maybe Durf tells us. And of course, he wouldn't include specifics, would he? But I'm telling you right now that is quite clearly a fisheye lens. The Earth appears to be concave at certain points there. Now, what would you do if I say I could show you a high altitude weather balloon footage with a camera that is known as non-fisheye and it shows curvature? Because that's quite easy to do.
Well, I mean, I've seen tons of different footage. Unfortunately, I haven't been able to do it for myself, so I'm just relying on other people's experiments.
But like this, all the footage you see from flat earthers is fisheye. All right, and they never tell you what the camera is. There was one flat earther who sent up a non-fisheye lens and quite clearly caught the curve, then tried to deny it. But could I show you a video, please, from a guy called Mr. Sensible?
No, sure. And I've seen, and believe me, I've been looking on both sides. I don't like being conned, no matter which position that I take. Right? We all want the truth. But I've seen plenty of footage from Globers, I guess that's what you want to call them, Globers. But the same thing will happen in those videos. I'll get a very nice curve, and then the camera will roll, and then it will go level, and then concave, convex. So I've seen it on both sides, and I understand 100% what you're saying. but this isn't like, you know, where it stops. So I know you can show me
Yeah,
other
yeah.
videos where, you know, there's a nice curve and
Well, let's have a look
Yeah,
at
but-
specifically Mr. Sensibles, because his is a great one.
oh,
Right, so this old baldy chap here is Mr. Sensible, and he decided to do what he called Mage, which is Mission Above Globe Earth. And here's what he made. So it's got on board, it's got 3 cameras. It's got this one looking straight forward in between these 2 reference strings, and this camera is a non-fisheye lens. It's, you know, minimal amount of fisheye, and it's got these reference strings which you can see are straight to show that anything in between those 2 lines is going to be, you know, representative of reality as long as those 2 lines are straight. It's also got 2 fisheye cameras, one pointing straight up at the balloon, and then one that looks behind it just for the view. And this ended up to, I think it got up to 36 kilometers. Here they are setting it off. If you guys aren't subscribed to Mr. Sensible, I'd love it if you did. God, that looks quite hard to hold down, doesn't it? But yeah, so they set it off, and off it goes. And there's a video on his channel showing the entire flight. And not only did it catch amazing footage of, for instance, the balloon popping whilst looking up, which is a concave lens, and you'll see, you know, a fisheye lens, and you see, because you can tell it's fisheye, it goes from concave to convex. So yeah, this lens is absolutely fisheye. But the lens that wasn't fisheye was the one that was looking straight forward and took these images. Anything in between these lines, which you saw was straight, is also going to be straight, or at least, you know, not straight, you know, relative of reality. And he goes through explaining what what type of distortion you have. But then this is what he calls the money shot. Where is it? Oh, there it is below. Right. So that image behind him there is at 35,162 meters, which also kind of shows that space is a thing because the atmospheric pressure is practically 0. And you can quite clearly see that in this non-fisheye lens, there's a curve to the horizon. He even overlays it with the predicted amount of curve that we should see at that horizon based on that level, based on the globe predictions. And as you can see, the prediction matches what we have. You know, the curve is there as we expected it to be. And I think this is, out of all the high altitude weather balloons I've seen, the one with the most controls, the one with the most attention to detail to give us an accurate view of what reality is. And no one has been able to debunk why this curve is here, quite clear for everyone to see. What do you think?
Well, I think at the end of the day, like, this is not going to do it for either side. I mean, you can make arguments for refraction and things like that, because, like, well, I'm just saying, like, there's no way to verify that, right? I mean, we can make predictions and stuff like that.
What do you mean there's no way to verify it? He did verify it. He sent this camera up and verified the prediction. Okay,
but I mean, if, like, okay, so we're looking out at the horizon. Would you agree that we can see the same distance and, you know, all, you know, points around us?
Well, that's what the horizon is. The horizon comes from the Greek word which meant bounding circle. And we say that horizon is equidistant at all points around us. So the horizon would be the same distance from him at all points around us, but the further he goes up, that point all around him is going to appear as a curve rather than flat, because he's seeing more of the geometry of the sphere. The closer you are to the ground, it's going to look
like,
flatter.
would you not agree that this horizon is at eye level?
No, there's nothing on here to determine what eye level is.
Okay, but it does rise with the camera as it goes up.
Well,
like,
horizon doesn't
stay at
rise
a
to
geometrical point and fall away from you. It seems to, in my point of view, it rises with you. But if you were to see this, you know, the same distances all the way around you, that would create. It's just wrong.
The horizon doesn't rise to eye level. The horizon simply. I mean, you're kind of arguing with Flat Earth at the moment, because Flat Earth has kind of dumped that argument since the sextant argument came about. But we can.
I mean, it just makes sense. Like, I don't.
We can see here that the horizon doesn't rise to eye level. This shows you what eye level is. Water is level. We know that, right? So if you've got these two pipes which connected water, if they're in line, then that is level. That is what eye level is. And just at 5,600 feet, the horizon has already dropped significantly. I don't know if Toon showed you this. I don't remember him doing so, but this is a picture that Toon took whilst he was on a plane with the Theodolite app, which actually shows you what eye level is. They're 1 degrees above eye level here, but the moon is below eye level, which means the horizon is way below that. The horizon just doesn't rise to eye level. The horizon actually does what we expect it to do on a sphere. Even at a very, very small distance like this, this is about 70 feet above the water, and you can see already the horizon has dropped, what I'd say quite a significant amount.
What is
here's
like?
the setup for that.
How can I verify that those, the liquid in those containers is eye level to the viewer?
Because that's what eye level would be. Eye level would be the point where those two bits of liquid are level. Atmospheric pressure will be creating the same force on each side of that tube, meaning that they will be level, so that can be a reference for what eye level is. And as you can see, when that's the case, it drops below eye level. This is a common way to figure out what eye level is. And as you can see, it drops.
Okay, but I mean, you could, with these shots that I'm seeing, you could simply just adjust the height of the camera to line up with the horizon. So that doesn't
work. Where I've lost that one. I've not got the pictures, but he actually does pictures showing that no matter how much the camera is dipped, it doesn't change the amount of what the line of level is.
Right, and like with these, with these observations, I definitely think that converging lines, convergence, and perspective does play a part in why it would drop a little bit. But
that's not what.
With that being said, at that altitude, I don't, based on the geometry of the sphere and everything that I've looked into, the horizon should be way below you. That's just what makes sense to me. But I'd like to focus on like things here on land that we can, visibly see, and just kind of go over the refraction that you guys are claiming. So,
so what is your issue with refraction? Refraction is the thing.
It's a lot of it's just presupposed, man. It's just wrapped around.
Nothing about refraction is presupposed. I don't know why you would say it's presupposed. Refraction is something that's experimentally verified. It's the properties and the way that refraction works are known properties that have been verified for years and years and years. Newton first started experimenting with refraction back in the 1600s, and modern day people like Andrew Thomas Young, the actual world's leading expert on refraction,
subject matter expert.
Yeah, he's done all the experiments and modeling and everything to know how refraction works. There is no presuppositions in refraction. We know the effects of refraction. We know what refraction should do based on certain conditions. So we can even model out simple things like the stupid black swan. Flat earthers say that, that destroys you, but no, because we can model that out based on globe predictions and known effects of refraction. Refraction's already been quantified, and unless you want to re-quantify all of refraction yourself, then there's no real argument against what we say about refraction.
Okay, but whenever you start quantifying and all that stuff, it to me, it takes away from reality. So if there's multiple observations, and Pablo's dog on YouTube, the past week, he's been doing some observations over in Santa Barbara, and in all different types of conditions. Did you say
once you start quantifying, it takes away from reality? So once you start measuring, and
so whenever you start modeling and
that takes away from reality.
So whenever you start modeling and throwing in your math equations, and you're pretty much saying this type of refraction has to be true because this is where we live. That's what I take away from it, man. Like,
well, what we say is this type of refraction happens because we've modeled out the effects of refraction. We understand the physics behind why it happens, and we know what difference in refractive conditions will do to the light that is hitting your eyes. I can demonstrate that refraction happens the way that we say it does. Like, the main point.
So you believe that there are superior mirages?
Sorry, do I what?
So do you believe that there are superior mirages?
That's one of the effects of refraction, yes.
Okay, like what conditions would cause a superior refraction? Because
What
all
do
I've
you
seen is
what do you think a
inferior
superior
from
mirage is? Something that is lifted up, from behind the horizon.
correct, but that's
Right.
because the
Okay. Well, I can
half of the
demonstrate that that's the
background
thing. If
is
you give me
being
one
miraged
sec.
as
Where's my
well, and you're pretty much
video?
just drawing a conclusion from what you're seeing. But if I can
Uh,
see it on, the clearest of days, and then when there's, a lot of distortion and blurriness and, then things are starting to be hid, well, that I can only take one thing away from that.
right. Give me 1 second. I'll
Refraction
share my.
is, to me, is making things look like they're hidden behind the curve,
No,
so
that's
called.
exactly the opposite of what we expect refraction to do. Bear with me, and I will get this video up for you. Right.
Okay.
So, the normal effects of refraction is that it makes light bend down. Even if the Earth were flat, that is what would happen. But
So that would be an
what
inferior mirage,
it would
or am I wrong?
no, if light's bending it down, it brings something up because it allows you to kind of see further. On a flat Earth, it would kind of work the other way, but even on a flat Earth, light would bend down through a gradient of density, and
So,
this
but
demonstrates
hold,
that to
hold on,
be the
Craig. We're
case.
presupposing the model, though, right? We're
No,
not
no, I'm
specifically
not.
just
I said either flat Earth or globe Earth, all right? And to be able to test
okay.
something, you have to make assumptions. That's part of science. But anyway, this is a demonstration of refraction. Now, refraction happens when it happens more when the air is denser and colder. It causes refraction to happen more than normal. And this is a demonstration of that happening over a relatively short distance, right? So, as you can see on this can, there's 3 bits of plasticine. Yellow at the bottom, red in the middle, green, blue at the top, okay? And he hides this can behind the horizon of this metal tank, which is curved, right? He sets the camera down, and you can see part of the can. You can see the top of it. So as you can see, the top there with just the blue. We know just underneath the blue there's a different color, right? I think it was red and yellow, right? So
Right.
our claim is that refraction, and the more refraction, the more it happens, will cause what is hidden behind the horizon to be lifted up because of the light bending down, right? That's the claim that you've got an issue with, yeah?
I mean, yeah, based on what, like, the observations
Right.
that I've seen, yes.
So this is what happens. So he pours some gas over it, which has a temperature of about 0 degrees C, which is what you would expect over kind of a lake at night. So there we go. Oops, oh, I skipped then, my bad. I tried to pause it, pressed the wrong button. So he pours the gas on it, changes the refractive conditions, increases the amount of refraction that's happening, right? Do it again, because I know I won't skip it. Right. And when he does that, when the refractive conditions increase, you can see the red, which was hidden behind the curve. But now the light has bent down around the curve of this tank and allowed what we see to be lifted up, because the light is hitting us. It's curving around the tank. And that is what is happening on a globe Earth when you see too far. It's refraction lifting up what is behind the curve. It's a physical thing. Yes, there's going to be distortions, especially in an extreme condition like this. But
Okay, yeah, that's what I was
over a
saying. That's
great
like
over a
major
great
distortion.
distance, this is what's happening. The bottom of something is being lifted up by the refractive conditions, allowing us to see further than we should. Does that make sense?
No, yeah, that makes sense. It's just, I mean, with the, the drastic curve of this barrel and the
Yes, of course there's
freezing or
drastic
what
curves.
zero
So
temperature gas that you're pouring on there, it just doesn't seem like a decent experiment to prove what's going on.
well, it
Like,
kind of matches the conditions that you see on Earth, because there's a curve, there's something hidden behind the horizon of that curve. This line here is the horizon that is an effect of this tank being curved, right? So what is here is hidden behind the horizon, which is the effect of the curve. And the light is causing, when it's being refracted more, it's causing what is hidden behind that horizon to lift up and allow us to see further than we should. We should not be able to see that red bit. Right now, we are seeing further than we should be able to, right? And that is exactly your claim. You said, well, we see too far. We see things that are too far that we should. But right now, in this case, we are seeing too far. We are seeing further than we should because of the refraction.
No, believe me, dude, I completely get your point here. It doesn't do it for me because when I look at Stone Mountain from Kennesaw, man, there's no distortion at all. I mean, there's no major distortion. There's no major temperature variations between the air and the ground. I mean, I can see it year round. So,
yeah, but can you see the whole thing?
That's really cool, man. And I'll need to look into that, but that doesn't do it for me. I mean, I'm pretty sure that's possible. That could have been manipulated somehow.
Well, it was manipulated.
I'm just going off the natural things.
That's what you do in an experiment. You manipulate your IV, right, which in this case was the density of the atmosphere, and your dV would be the amount of refraction caused, and that's exactly what he did there. He manipulated the density and the temperature of the atmosphere, which is what you need to do in an experiment to try and show that your hypothesis is correct, and that's exactly what he's done there. If you run through the quantum erasure version of the scientific method, he had an observation of seeing too far. So he had a hypothesis that it's refraction bringing things up from behind the horizon, made a prediction that would happen in this case, and performed the experiment to test the hypothesis, following the third grade version of the scientific method that quantum erasure sticks to so hard. So that's exactly what we expect to see. And it completely destroys the black swan, because it shows that refraction can lift everything up from behind the horizon. What we see on the black swan is literally a prediction of the globe, not a presupposition, a prediction based on well-known facts. That's not an assumption.
Okay, so like the other black swan photos where the oil rigs are hidden. So would you say that that's the geometric horizon, as like I've always been told, or is that?
Well, you can never see the geometric horizon under any condition, unless all the atmosphere is ripped off of Earth, right? You would never be able to see the geometric horizon. In that case, your eyeballs would probably boil out your skull anyway. But we don't see the geometric horizon.
But you understand, like that is a very recent argument on the globe behalf.
Not really.
Still, the science communicators
only
will tell us
we've
that.
had to explain refraction more. We've all had to look into refraction more so that we can explain it better. That's how you become a better teacher, is you constantly learn. So yeah, that is what I'm saying about not really seeing the geometric horizon. That particular phrasing is relatively new, but that's the truth, right? And here's a way to think about it: you never see anything as it is, ever. Right? You don't see the geometric horizon because the air is refracting it, and light takes time to see your eyes. Even you right now, looking at the screen in front of you, if you look at your hand in front of you, and this sounds stupid, but it's not, you aren't seeing your hand where it is right now. Because one, the light between your hand and your eyes is causing it to be refracted some amount, and that light has to travel after bouncing off your hand into your eyes. So you're seeing your hand refracted and slightly back in time. It's damn near close to where it is, but you never see anything where it is. So asking the question, is that the geometric horizon, is kind of redundant, because no, we are never going to see the geometric horizon. We see a refracted version of the geometric horizon, but the fact there's a horizon at all shows that the Earth can't be flat, because there's no reason a horizon would happen so sharply if the Earth was flat. It damn well wouldn't be so close as we see it, that's for sure.
No, I mean, I hear where you're coming from, man, but like all of the observations that I've seen are just inferior mirages, things that are being reflected below the actual, the physical object in which you're viewing, whether it's a road, cars driving on it. And you can verify that from, past days observations.
Sorry, just 1 second. So I just want to say hello to Nathan Scum Thompson in the chat, taking time out from abusing his dog. That's nice to see you here. No, the horizon is not the curve of the Earth. It's an effect of the curve of the Earth. It's there because the Earth is curved. Your lack of understanding is your problem. Go and feed your dog some meat, you fucking idiot. Sorry.
You guys are good friends, huh?
I detest very few people, but Nathan Thompson is definitely one of those. Stay away from children, you fucking numpty. You can't support Nathan Thompson, surely.
No, man. I go on my own observations, man. I think things that other
What do you
people
think of
present
Nathan
are
Thompson
interesting.
shouting at kids in a school?
I mean, it is what it is, man. I'm not gonna sit here and judge anybody. I mean, I think what he was trying to do is just trying to get the word out, man. He feels like people have been lied to and they should know the truth, and I think that's how a lot
And
of flat
that's not the
earthers
way to do
feel.
it.
But
Anyway, as off topic, I just really detest Nathan Thompson, and
I got you.
I would only ever debate you once more, Nathan Thompson, and it would have to be moderated. And you'd have to also pay me $5,000 to be anywhere fucking near me. Right. Anyway, so yeah, all the times that we see too far, it is simply what we expect from refraction. Right? You agree that refraction's a thing. I've just shown you what refraction does. So how does the fact that we can see too far not get explained by refraction?
Well, can I show you a few things and you just kind of
Yes,
explain it to me?
certainly.
Okay.
So you should be able to share screen, and I'll put it up. That's what she said. Oh, I think you just stopped sharing screen there.
Oh, yeah, let me go back. Okay.
Sorry, give me 1 second. I'll get your screen up. There we go. Oh, you don't need to time out, Nathan. Let him spew his nonsense, because it's always funny. But unless he is horrible, don't time him out just for being Nathan. It's always fun to laugh.
So what would you say that's happening here?
I would say that that's a form of refraction, which is very different to what you would get over water. In fact, that's kind of the opposite as to what you would get over water, because you're having more warmth coming off of the ground rather than more cold, which you get coming off of the water. So that is a type of refraction, but that's the refraction we would expect over a hard, hot surface compared to a cold, wet surface.
Okay, so what, just from your point of view and your position, what type of miraging would this be?
Would this be a positive coefficient.
So that would be an inferior mirage.
Well, it seems to be a whole bunch of different refractive effects going on. There's clearly some kind of thermal inversion going on. You can see halfway along it kind of changes and goes up and then down. That is refraction, but again, that is refraction over a hot, hard surface. And that's what we expect over 100%. A hot, hard surface. And it's kind of the opposite that you would see over a cold, wet surface.
100%. So the oceans are cooler than the air above it, right? We can all agree to that.
Yeah, so the refractive effects that you have coming off of them are different, because this is literally kind of emanating heat, whereas
So your position would be that over water, the images would be, refracting upwards.
Yeah.
From the actual physical oil rig or whatever.
Yeah, that's why on times you can see too far, because in general, over water, refraction makes light bend down because of the gradient of temperature that you get.
Right, but here we're getting the same thing as on the road. It's being refracted downwards. So here's the physical oil rig, right? We know the legs aren't actually this long at this distance, but it's being refracted on the water, and we can see the horizon beyond it. And I think
that's clouds behind it. You can see.
Pretty sure that's an island back. It's 50 something miles away, he explains. And I've went on Google Earth.
To me, that looks like you've got water and then clouds in the sky that are, both are kind of forming a horizon. But the darker blue along where the legs are is the horizon of the water. The ones above that, I'm almost certain those are clouds, not the horizon of the water.
No, that's actually more land back here. He's looking through a bay area.
Land and clouds, and I'd say, yeah.
Yeah, there's several oil rigs that you can verify all of it.
I mean, like I said, you can get lots of different refractive conditions, and what you're seeing here is going to be an outlier, right? This is not what you would see on most days.
Oh, he did it all week long and different times of the day. So this is like really heavy refractive conditions, and you can see the miraging that's happening below it. We wouldn't say that the physical oil rig is right here on this horizon and being lifted upwards.
No, because like I said, everything is refracted. But I mean, we could probably model out this and why it happens on
right. I know we
Earth.
could model it, but I have to know, right? If these are 13 miles away, where is, like, I don't understand what's happening here. I see from what I'm looking at, there's an oil rig and it's being miraged below it at 13 miles, and he's at like 40 feet above sea level, is what he said in the video, and that's just a problem.
Well, it's not a problem because again, it's one of the refractive conditions that we expect to happen on the globe, and if we can model it out to match the globe, then it matches the predictions. The problem is that
but how can I verify
seeing the horizon at
model?
different, by doing experiments yourself that take what refraction is into account, or by listening to the experts who've already done that, like all the people that have actually fucking measured the Earth. All the surveyors.
Well, I mean,
who
we've
do
already
their job.
we've already
Jesse Quillassi,
yeah, I mean, I've already
who
told everybody
measured
I
the
don't
curvature
really
of the
trust
Earth over 1 mile,
Yeah.
1.38 miles of lake. The fact that there is curvature over a lake with 1.38 miles between coasts shows that water curves on a large scale. So, but refraction is a thing, right? No one's denying that refraction is a thing.
I'm not.
And
Yeah, no, I'm
refraction
not
can cause
denying it. I'm
things
just
to look
saying refraction
extremely
is
different.
not what you're claiming.
But it is refraction. There is many different types of refractive effects. Obviously, there's some extreme refractive effects going on here, which are different to what you would normally see on most occasions, right? Normally when you're looking at for instance, when you're looking at the black swan, normally you don't see the horizon behind the second oil rig. Normally you see the second oil rig
Craig,
mostly obscured by the horizon.
Yeah, the horizon is behind the oil rigs. It looks like it's below it, but that's just the beginning of the mirage, and then you can
it's very hard to tell where the horizon is here because there's extreme refractive conditions. But again, refraction is something we expect to happen on the globe. So it can't be evidence that the Earth is flat if it's something that we expect to happen on the globe.
Well, I mean, yeah, because you're looking for an outcome, and you're saying, well, this could happen.
No, we're not looking for an outcome.
Model,
we're predicting something, and we're testing to see if that happens, which is how science works, right? You do agree that that's how science works. That you
and it could work both ways, and it proves neither. So
science doesn't prove anything.
From my opinion, man,
that's science is. If you're trying to prove something, that's complete pseudoscience because science.
But I mean, here
he
shows a time lapse of this land.
Yeah, this one's great. I love this one because this one shows exactly what we say. It shows that refraction can literally lift the horizon up and down throughout the day. This is what we claim.
Right? Well, that's what I mean. Like I said, recently I've heard you guys say, look, there's an apparent horizon when before it was a geometric horizon. Not even too long ago when I first started looking into this.
Well,
so,
yeah,
but you can see here, like refraction will hide.
Right, so here's the thing: there is a geometric horizon. Of course there is, but we don't ever see the geometric horizon, and that's the point.
You understand how that sounds, Craig?
If we're talking about refraction, we have to take into account the fact we never see that. Sorry.
Right, you're saying it's there, but we don't see it like that.
Of course we don't, because of refraction.
I know, but refraction to me is not doing what you're saying that it's doing.
I showed you refraction does what we say. When you have the conditions that allow
example,
you to see
man,
further,
just didn't do it to like this is reality here. This is
I showed you reality.
This is different.
I showed you reality. I showed you someone
we
in
showed
reality
you an experiment
doing
with some
which
gases
is reality, right? That's what science is. And
okay, well, that was
to quote Richard Feynman, if it doesn't agree with experiment, then it is wrong. He showed an experiment doing what we say refraction does under those conditions in an experiment, which means it was done in nature, which is reality. So I've shown you reality and you're denying it. What I'm saying here is, yes, I see the refraction, and that refraction is what we expect to happen under the conditions on Earth.
I don't agree, man.
You can
I mean,
disagree all you
there's
like.
not
it doesn't
enough.
change the
There's
facts.
not enough being
Right,
lifted up
why do you?
in here to
Wait,
substantiate.
hold on. Why do you disagree with all the world's experts about refraction? Do you think you know more about refraction than all of the world's experts on refraction?
Hey man, I trust my eyes, man. And I know
No,
the tunes like,
it was
yo,
a
don't
yes.
trust
It
your
was a yes
eyes.
or
I
no
can show
question.
you.
It was a yes or no question. Do you think you know more about refraction than all the world's experts on refraction?
I mean, based off of people's observations, like Pablo's dog over a week. I mean, it's not.
So you
it's
do
not
think
this,
you
it's
know
not
more about
lifting
refraction?
objects up.
So wait. So you do think you know more about refraction than all of the world's experts on refraction? You think you know more about refraction than Andrew Thomas Young? Yeah.
I mean, a book said a thing, man. Like
Not a book said a
it's the
thing.
same-
Someone who spent their life studying that thing, doing experiments and verifying and quantifying that thing, has become an expert in that thing because of the amount of time they spent doing that thing. And you think you know more than that person who is literally the world's leading expert on that thing. Is that right?
Okay, well, let's not put words in my mouth. I never said that I knew more than these people. Okay.
Well, if you
But
don't know
what
more
I'm
than
saying
them,
is from the
then
observations
when they say
that have
that
been-
refraction is happening and that's what we expect, then why don't you listen to what they're saying? Why do you disagree with them? Because that would say that you know more than them.
Like I said, based on the observations that have been presented with both sides, I mean, the flat Earth argument, to me, it trumps. I mean,
Where does the bottom of things go then?
because I can't verify anything that you're saying. You're saying, okay, well, if we had
You could, Andrew
a
Thomas,
spherical
all of
Earth,
Andrew
and then we
Thomas's
put it in
work.
this diagram, and then I do
Hold on. You
this
said you can't
math.
verify anything I've said. All of Andrew Thomas's work is available for free on his university's website. All of it. You can go and verify it yourself. It even describes the experiments that he's done and how he's come to the conclusions, and allows you to, rewrite the modeling program that he wrote himself to show that it's based on reality. The fact is that if the world worked the way you guys say it does, and refraction works the way that you guys say it would, we would be able to zoom things back in once they disappeared over the horizon, and that's something we just can't do. So, one sec. I want to show you Dazzler the cameraman's video. If you give me a second. You still there? You seem to have gone quiet.
Sorry, I was on mute.
Alright, okay, so... This is Dazzler the cameraman, P1000 in Australia, looking at some boats on the horizon. Okay, you can see you've got 3 boats here, one quite clear in the middle, one to the right, and then one just to the left, which has pretty much been obscured by the horizon at this point. If what you guys are saying is true, then you should be able to just zoom in and see more of what's there. Right? That's
Okay, but if that's not the geometric horizon blocking the boat, well, then we still have to hold the same position that that's an apparent horizon, sphere or flat, correct?
Yeah, absolutely. But a horizon wouldn't block anything if the Earth was flat.
Okay, so in my reality, without relying on X...
If the Earth was flat, a horizon wouldn't block anything, would it? Because the horizon is a physical effect of the curve of the Earth. So,
well, I think that's an opinion that you can hold if you're a glober, but...
What do you mean an opinion? That's what it is. That's a fact. The horizon is a physical effect because the Earth is curving. If the Earth is flat,
so you think you should
there's no reason something should be hidden behind a horizon.
So you think on a flat Earth, we should be able to see forever? Or
if there's nothing in the way,
larger
then, yeah.
distances.
Certainly,
well, there's atmosphere,
things
right?
should not just disappear from the bottom up quite clearly, right? Which is the case of what we see here. So, as
it just sounds conflicting, man, because you're.
It's not conflicting.
I don't know. I feel like you're holding contradictory. Like,
no, we're not holding.
here.
The apparent horizon can still block things just because it's apparent. It can still be, it's still a thing. We're just seeing a refracted version of it. You know, we're seeing where refraction has made it appear. It's still a physical thing.
100%. So
it's still a physical
right. So
thing.
the argument really comes down to what do you want the refraction to say? Like, what do you,
we
what
don't
do you
want refraction to say anything.
We
We just follow
I mean,
what was the known effects of refraction, right? But like, if refraction worked the way you guys say it is, and you know everything about flat Earth, about the horizon that you guys say is true, then as you zoom in on something, you should be able to bring it back into view, right? Which is something that you can't do, all right? So as Dazza the cameraman zooms in on these ships, he takes a screenshot. So screenshot taken there of how much of that ship is above the horizon, all right? And then he zooms in some more. Come on, Dazza, hurry up. Should probably speed up the video. Right, so yeah, so he zooms in some more. Screenshot taken. And then another one. So as you can see, when he was zoomed out, how much of the ship was visible on the left above the horizon? Just the masts and the bridge tower. And it's exactly the same amount as when zoomed in all the way, showing that zooming in doesn't make things appear back above the horizon. Which, if the Earth was flat and things did go behind the horizon, which there's no reason they would do, but if the Earth was flat and that was the case, then zooming in would bring them back. If refraction works the way that you guys say it does, then zooming in would bring things back, but that just doesn't happen. What refractive conditions over cold, dense water could cause that to happen with no distortion? And that's the big thing here, is that there is refraction going on because you can see quite far, but it's still minimal refraction. There's no distortion, there's no waviness. It's very clear what's happening.
Like, how far away is the ship on the right? This
ship is 8.6 miles away.
Okay, and the other ship, do we know?
This one is 12.8 miles away, I believe, or 12.4.
And the viewer's height?
30 feet, I believe. Let me see. 30 feet above the water. The distant ship 12.6, the closer one 8.86.
And that's not a problem?
No, because refraction can allow you to see too far, as I showed.
So it can, but also hide things, because I mean it's.
Well, no, refraction.
Is the position you're holding not that the ship on the right is being lifted due to refraction, and then the other one's being hidden by the curve?
They're both being lifted by refraction. You know, if we were to just take the geometric into account, which we can't because there's refraction, then both of those would be kind of over the curve. But it's taking longer for them to go over the curve because of refraction, but it's showing you that they go over the curve. They go over the horizon, which is an effect of the curve. And once that's happened, you can't bring them back.
But I'm not seeing major distortion here, like how you were showing in your example with the gases and things being lifted up. So if that was evidence, I would be looking for that in all of my observations.
But again, what I showed you with the can was an extreme case over short distances to demonstrate the fact that horizon allows us to see too far. Now, this is a much lower amount of refraction compared to that over a much larger distance, which allows us to see that it's pretty calm and pretty clear, but still allow the refractive conditions of, you know, it to lift things up, which is what we would expect it to happen, be the Earth flat or round. But the main point here is that there is no distortion, and most of that ship is hidden by the horizon. So what's causing that if the Earth is flat?
Okay, so I'm pretty sure the alternative argument is atmospheric compression. Is that a thing that we can agree on?
Atmosphere doesn't compress things. It's not a circular lens. The atmosphere is a lens that has.
So there's no atmospheric compression?
No, because that would cause that would be a circular lens to kind of compress things like that.
Okay, well, I've seen multiple observations of buildings very far away, and you know all of these buildings
you do get with refraction, you do get things that can look compressed, but what you're seeing here is there is no distortion, there is no compression. The amount of relative size of those pillars is exactly the same. There is no compression or anything happening here. The only thing that's happening is that you can see quite far, because that's the general effect of refraction, and the boat is being hidden by the horizon. And the flat Earth doesn't have an explanation for why this happens so clearly.
I'm pretty sure it's just atmospheric compression, you know.
Well, where's the
the ship on the
distortion
right?
from that,
That's not the entire bottom of the ship. There's some that's being hidden due to the the waves.
The entire bottom
and,
of that ship
forefront.
is hidden, right? It's either mostly underwater or hidden by the horizon, which is an effect of the curve of the Earth.
I mean, that could be your argument. I mean, in another argument,
where's
is
all
that
the
it's just
compression and wavy
atmospheric
distortion and
compression
stuff
and refraction. I mean,
but that's not what refraction does in conditions like this. According to all known experts on refraction, all known experiments on refraction, all quantification of refraction, refraction in conditions like this doesn't do what you are saying. So again, you're saying that you know more than all the world's experts of refraction. Like, why don't you write a paper and get a Nobel Prize by debunking Newton?
man, I like building stuff. Man, I like being a carpenter. But listen, like other observations, man, like atmospheric compression is a thing. Like you could take skyscrapers, you know, at a distance, which, you know, honestly, I don't think you should be able to see due to the, you know, the geometry of the globe. But, and especially the ones like on the beach, I mean, you can see the building, you know, all the floors are the same size. And as you pan down the building, you know, they go from, you know, normal size and they get smaller and smaller and smaller. And eventually it's all compressed at the bottom.
Yeah, but
So that's
that
what
I
that
showed
would
you
be
just then
my
was
argument
compressed.
with the ship.
But nothing I showed you was compressed. All the, you know, relative distances and relative sizes of everything is the same as the ship in the foreground. There is no compression going on. And in that, you know, you can watch the videos of it going over the horizon and staying like that, you know. And there's no reason why.
Well, I think
there's no reason why you would have the compression you're talking about without other refractive conditions, like, you know, it actually being squished. And there's no squishing or anything going on there, none at all. It's purely just the ship hidden by the horizon.
the apparent horizon.
Yeah, the apparent horizon. Yeah,
in a
it's still the
refraction
horizon.
band, or, you know, as the Plain Truth likes to call it, the Aether band.
Yeah, no such thing as
Right?
the Aether band, and the Plain Truth fucking hates me. Like, he sent me so many abusive messages. I love triggering flat earthers. It's hilarious.
I got you.
But the thing is,
I mean, yeah, man, we can agree to
refraction is the
disagree
thing,
on that,
right?
but
Your main argument is that we see too far, but refraction is a thing, and it can answer all your questions. If we can model it out to globe predictions, then it's what we expect to happen, and we can model them all out. They all match a globe prediction, but they don't match a flat Earth prediction as to how refraction would work, because the world's leading expert, subject matter expert Andrew Thomas Young, also did an entire investigation into what refraction would look like if the Earth was flat, and things like superior mirages would be completely impossible if the Earth was flat with the known effects of refraction. I encourage everyone to go and look at Andrew Thomas's Young investigation into flat Earth and refraction. You know, and this is the world's leading expert saying that, yeah, it wouldn't work if the Earth was flat. So do you have anything other than disagreeing with all the world's experts on refraction?
I mean, you know, besides the fact that they all think that they live on a sphere, so they're, you know, they're presupposing what should be happening.
No, you don't presuppose.
And I know you say, Craig, I know you say you can model it, man, and that does nothing for me. I mean, we don't live.
Well, that's
on
very
a
important
model.
in science,
I mean,
because you need to be able to make predictions, and that's what models are for.
I mean, we could do that for.
There's no flat Earth model. Please don't say there's a flat Earth model, because there's not.
No, man, I'm a baby flat earther, man. I just started looking into this, but
Okay, so right, baby flat earther. Simple question: why is there no working map?
because I mean, I want to go the religious route, but I mean, in the Bible it says we'll never measure the earth. I don't think we're able able to. I don't think
Bible
it's,
also
it's
says Earth's
possible.
a
I don't think
sphere,
we
but,
understand the true nature of the sky and the celestial bodies. I don't think we're supposed to. We can speculate all day, but
I mean, we've been there, but
there's problems
interestingly,
on both sides when it
interesting.
comes
The
to that.
Bible specifically says the Earth's a sphere, so that's always fun to mention.
I
And
mean,
in
Isaiah
space.
20:44, we can take away the circle as, you know, a flat circle. So
No. Like Job 20:40, I think, talks about the looking down on the globe of Earth. The Earth. It talk, you know, in the New King James version, it talks about the Earth being hung in empty space. So you know, it's not on anything. The Earth, in several translations of the Bible, it specifically says the Earth is a sphere in space, right? That's just in some translations, but in no translation does it say that the Earth is flat anywhere. That's an interesting thing. However, the Bible is also a book written by sheep herders several thousand years ago about a magic sky daddy, and I really don't think is important to the question about the shape of the Earth, which, regardless of what the Bible says, has absolutely been measured several times. Hundreds of times, thousands, possibly millions of times.
I got you, man. It could be debated, you know, all night long, man. But
I mean, it
I'll
can
have to
be.
disagree with you about the other Bible verses. I've looked through it. I haven't seen any, you know, referring to a sphere or a globe. You know, when it says God is all seeing and all knowing, you can't see everything on a sphere. I mean, that's just what I take away from it. The circle of Earth,
Why
looking
wouldn't
down
God
upon
be
a
able to
flat
see
Earth
everything on a
makes.
sphere? Isn't he magic?
I mean,
and
and
all
anybody
knowing?
who looks at that, they would have to agree that that makes more
What
sense.
a puny God!
Um,
Why couldn't God make a sphere in a vast universe? Is he only capable of making a little snow globe?
I think that's just your opinion, man.
Well, no, I'm genuinely interested. If God is all powerful and all knowing, why did he make just a little snow globe and not the wonderful vast universe?
I don't know. That's your journey, but I have
So,
some other.
I just read it to you.
You want to talk
Isaiah
about the
forty
local
twenty
sun?
two, in several translations, including the Message, Paseta Holy Bible, Dari Reims Bible, it says, "And him who sits on the sphere of the earth and its inhabitants are like grasshoppers," or "God sits high above the round ball of earth," or "It is he that sitteth upon the globe of the earth." And then several times it says the earth's in space in Job 26:7. He spreads the skies over unformed space, hangs the earth out in empty space. Or God who hung the northern sky and suspended the earth on empty space. I mean, that's the thing, right? The Bible was a book written by sheep herders thousands of years ago that has been translated and retranslated and mistranslated and reinterpreted, bits taken out, bits added, and is really not something that we should use now to look at what the universe is. The Bible is full of so many contradictions, inconsistencies, straight out lies, and horrific genocide and stuff. I really don't think that nowadays the Bible is a book that we should look at to tell us about the universe. That was never what it was intended for. What we should do is actually look at empirical evidence. Like, if the Earth is flat, you also say it's stationary, yeah? You say it's not spinning.
I mean, when I walk outside, man, I'm outside all day, man. We do backyards and stuff like that, man. I don't feel like I'm spinning when the sun comes overhead. It's hot. It feels local. So I mean,
yeah, you don't.
I know
feel
you can call me.
constant
You can
motion,
call me
of course.
stupid, bro, all you want, man. But
I mean, you kind of show it yourself, to be honest. But it's not. You don't feel a constant motion, and the Earth is rotating at a constant speed. But if the if the Earth isn't rotating, then again, why can we measure that it is rotating?
Well, I'm told by science communicators that we're speeding up and slowing down. So it's, to me, that's not constant.
Well,
So,
are you talking about Earth's orbit around the sun?
Well, yeah.
Well, Earth's orbit around the sun is elliptical, so there is slight acceleration and deceleration, but it actually equates to about 0.004 meters per second over 6 months, which is very, very little and not something you would notice. But the Earth's actual rotation is a constant 15.04 degrees per hour. And again, if it's not rotating, why can we measure that it is?
Well, I've heard that that was measured with gyroscopes, but then it measured differently at different elevations.
No,
So I feel like
Bob's
there's
never.
some conflicting.
That's a claim from Bob, but the data he released actually disagreed with him and showed that it was always within the margin of error of the gyroscope that he was using, never outside of the margin of error. It always registered a 15.04 degrees per hour drift. But it's not just that gyroscope that Bob used. He had someone build a mechanical gyroscope which measured the same thing. You can even measure the rotation
Okay, but
of
if
the
we
Earth with a swinging
hypothesize,
pendulum.
right? But if we hypothesize about like an electromagnetic field and you know that's what is causing gravity, could that not manipulate these experiments? And
Electromagnetic.
construe them?
Did you just say electromagnetic is causing gravity? Who says that?
Well, I mean, it's the toroidal field. From what I've looked into it,
No,
it makes sense.
electromagnetism
So it's
isn't
a
gravity,
residual
very
effect
different.
of electromagnetism.
Yeah, no, gravity isn't electromagnetism because it would affect different materials differently, which it doesn't. And also, Bob's experiment wouldn't be affected by an electromagnetic field because a fiber optic gyroscope uses light, and light doesn't have a positive or a negative to it. It's zero charge. So light itself is not affected by electromagnetic fields.
I got you. I mean, to be honest with you, I don't know everything about it, but if there's other things that could be manipulating these experiments
Like
that
what?
we don't know about because the mainstream has not chosen to study them, well then
Like what?
we
though?
can't
There's-
we can't rule any of that out. So
I mean,
if
the
we're,
aether's
if we're
been ruled out
basically
for,
just
100
accepting the theory of gravity and we're not
gravity
looking any
isn't just a
further.
theory. Right. Anyway, we haven't ruled anything out.
Well, the causation is a theory, right? We can measure gravity. We know things fall, right? So
yeah. Well, we also know that
but
it's
I think
because
the
mass warps
causation
space.
is the
We also
assumption.
know. We also know that it's because mass warps spacetime. It's been demonstrated empirically with experiments. But
Can
the
you
fact
please
that
demonstrate an experiment?
we've demonstrated that mass warp spacetime via experimentation. That's been done.
Right, I've never seen them though. I've looked.
Well,
I
the
haven't
big
seen
one,
any.
the
I was
Eddington
hoping you could
experiment of
present one for me.
1919, of course.
I'm sorry.
The Eddington experiment of 1919 was a great one.
Okay, I'm gonna look to it.
So it shows that gravity, that mass warps space-time, which is what causes gravity. So it seems to me that your entire thing is you don't understand physics and you've listened to some con men online.
I mean, I could say the same thing about you. You read in some books that somebody gave you. I mean, it's
No,
it could go either way,
I
man.
studied and tested the world myself.
I mean, yeah. I mean, I've tested it too. I can see Stone Mountain from Kennesaw.
Yeah,
It's
yeah,
like
but you're
50 miles
ignoring
from-
things like refraction. You can't test something.
Okay, well,
if
we
you're
have
going to
already
ignore
agreed that
variables.
refraction comes with refraction as major distortion, like in your example.
Not always,
Like we
no.
knew that the
No,
red
not
ring
always.
was not
Not
that
always
wide,
is there
but
major
it appeared that wide once it was refracted.
Not
So
always is there major
Stone
distortion.
Mountain is not distorted. when I view
You're
it
ignoring
from
me here.
Kennesaw.
Not always is there major distortion. That's
I'm not
a straw
ignoring
man.
you.
You were ignoring me because you said we agreed because there's always major distortion. No, we do not agree. There is not always major distortion. That is not a fact.
Well, that was an example to prove that things are lifted up. So
Yeah, in
just
that
because you show
extreme
me
condition-
observations, we can have difference of opinions of what we're
No,
seeing.
again,
but if
I don't
your
have an
example
opinion.
to
I base my position on all of the evidence available, which you are ignoring. You are ignoring all the hundreds of years of evidence about refraction. And
Craig,
just
that
going with
one piece of
misunderstanding
evidence
what you're
that you
seeing.
showed me was, Craig, the one piece of evidence that you showed me was you pouring, was it nitrous gas over a drastic curve?
Showing that
Okay,
showing that
it was-
refraction
it
lifts
was-
things up.
Okay, but
Which
in
it
that
does.
example, it was drastically distorted. You could tell that
Yes,
that wasn't
in that
act-
example, but it
was-
still shows that a refraction does what we say it does and lifts things up when there is more refraction. But not always will there be distortions. If there is a continual gradient that's exactly the same, then you will still get the refractive conditions of lifting things up, but you won't get the distortion like that. If the refractive
How
conditions...
can I verify
Wait,
that?
By going out, right, the way that you could verify it if you really want to, but what you're doing right now is practicing pseudoscience by putting your own personal standards on science. But if you wanted to verify
have
that,
any
the
personal
way that you would
standards. I
need
just
to
wanna-
do
I
it,
want the
listen,
truth.
the way that you would need to do it is to go out to sea for several miles and measure the temperature and density of the air above the water at several points, and then use those measurements that you have taken to observe refractive effects along that line of measurements that you've taken, and do that for every day for a year. And then you could maybe disagree with all the experiments that have been done throughout history. Are you willing to do that? Or are you going to maybe listen to the experts that disagree with you?
No, I still got to pay rent, man. I can't go to sea for a year. But Pablo's dog, I mean, that's literally what he's doing right now. And he's literally taking the atmospheric conditions, the temperature of the water.
And it all matches the globe predictions. Everything that he does will match the globe predictions 100%.
Yeah, and it could match the Flat Earth's predictions as well.
No, it doesn't match. It doesn't match Flat Earth predictions. Again, you can find the Flat Earth predictions on Andrew Thomas Young's website on his university, where he did the Flat Earth predictions. And it doesn't match what we see in reality. So you have to ignore everything. Right, you have to ignore all of science to hold your position. You have to ignore all of physics to hold your position. You have to ignore Newton's laws of motion. You have to ignore the conservation of momentum. You have to ignore all the millions and millions of pictures from space, be it from governments or independents. You have to ignore everything and think that everyone is fucking lying to you because you think the Earth is flat. How many people across the world would have to
Andrew Thomas Young is literally just saying the light is bending and it's lifting things up because the Earth is a sphere. That's pretty much what it's saying, man.
Yeah, because it's been measured, the measurements that he has, and he maps out what happens, compares it to both flat Earth and the globe Earth, and he doesn't say it's because it's a sphere. He takes that into account with his calculations. But there's also experiments in refraction that isn't talking about the curve of the Earth. He does many experiments and investigations into refraction over short distances and how it reacts to different changes in medium. Andrew Thomas Young, again, has done all of the research, and he compared it to a flat Earth or a globe Earth. And what happens is when all the it models out and compares it to reality, the reality we see is that Earth is a globe.
Yeah, I disagree, man.
So you so you do disagree with all of the world's experts on refraction?
I do not agree with what he's taken away with his experiments about refraction.
Right,
because,
so you
simple observations
disagree. So that is Dunning-Kruger personified. You are top left, right? You have started thinking you know something about refraction, and all of a sudden, you are the most very expert at refraction. So much of an expert that you know more than all of the world's experts. And that is because you've never actually studied refraction. If you started to study refraction, you would realize that you know nothing about refraction and need to learn about refraction.
Okay, well, the subject matter expert literally went into his experiments presupposing a sphere, so he had to wrap what he was seeing around 100%.
No, he didn't.
So, and then he could say, "Oh, well, on a flat Earth,
no, you're strawmanning him. He didn't do that.
But that does not line up with observations that people are clearly doing this week.
You lied. You said he went into everything assuming Earth is a sphere. That's not the case. We don't need to assume Earth is a sphere. It's been measured. No assumptions are required if we have a measurement.
You can hold that position all you want.
It's not just a position, it's a fact.
And the only
there are
that
hundreds of thousands of measurements of the curve of the Earth. I'm not going to ignore all the measurements that have been done just to believe Earth is a fantasy pizza land.
You're really against a flat Earth, aren't you?
Yeah, because it's fucking stupid, and it's not okay to say the Earth is flat. Here's why I'm so against it, right? To think the Earth is flat, you have to think that everyone is lying to you. Everyone. Every scientist, every newsreader, every teacher, every person that studies physics, ever. Every pilot, every boat captain, every military personnel. I was in the military. I traveled the world. I can tell you it's not flat. Everyone that works in Antarctica, everyone that works for any airline ever across the world. All of these people, all the people across government, all their aides, all their advisors, all reporters on the news, all these people, every ex-leader, everyone, millions and millions, billions of people would have to be lying about the shape of the Earth.
So you think that they just all tell the truth? Do you think the government doesn't lie one bit.
That's irrelevant to the conversation.
It's
They're
not
not lying
irrelevant,
about the
Fred.
shape of the
A
Earth
liar
because
is
so
a
many
liar,
people would have to
brother.
lie. All right, I've worked for the government. I was a Royal Navy nuclear engineer
And you
for
were
many
not
years,
allowed to
and
disclose
I have
certain things
tested
about
the
the
shape
Navy.
of the Earth.
And you were not allowed to disclose certain things that you knew in the Navy. Some
Yeah, I'm
things
certainly
you
not
had
allowed to
keep
tell you
confidential.
about
It's
how the nuclear
compartmentalized.
technology works because I signed the Official Secrets Act.
Right.
But
So if there was
nothing in the
some-
Official Secrets Act said the Earth is flat and you aren't allowed to say so.
Okay, so let's speculate a little bit. So if there was something about
Or we could talk about
humanity
science.
knowing that the Earth is flat, that they had to keep a secret, you don't think that they would do it?
No. And if they did do it, then they would have given it up at some point in their life.
Bro.
The billions of people that would have to be involved, somebody would have given it up at some point. Somebody on their deathbed would have said, "Here's all the proof that it's lying."
of
Right?
astronauts
It is
literally saying the
mathematically
Earth is flat,
impossible
dude.
for that many people to keep that secret. All right, I am not
Did you
lying
see
to
the
you.
video of the? Okay, did you see the video of the Polish astronaut? I think it was Polish. Literally saying the
yeah,
Earth is flat,
laughing at
nobody's been to
people.
space.
Laughing at people.
Okay, but you're saying nobody would say anything. Well, there's one. Okay,
He was
and those
laughing.
pilots-
He even says in the next interview, "Yeah, I was making fun of flat earthers."
Okay, but dude, there's tons of pilots that have said the Earth is flat. There's videos of it.
No pilots.
Are
think
they
the-
all
well,
just
There's
faking
one
it?
pilot that I've met that thinks the Earth is flat, and he just flies like crop duster planes. But every single pilot that flies a big aircraft knows that the Earth is spherical because they have to use instrumentation that take that into account. Every single pilot that you've seen a flat earther record, "Is the Earth flat?" And they go, "Yeah." It's because they want to get the fucking crazy out of their flight deck. And they're laughing at you. Pilots have to use something called the Haversine formula to calculate their flight routes. The Haversine formula only works if the Earth is a globe.
I mean, I've heard testimony from F-16 pilots. I mean, all kinds of pilots, man, and they say that there's no curvature.
Any
or
pilot that
anything.
says it
It's
is
flat.
laughing at you because their instrumentation
Okay, so
works based
Alright,
on the
so-
Earth being a globe. You cannot be
Okay, so-
a international pilot and think the Earth is flat because it is incompatible with your job.
all right, so let's just go back one step. So we agree that governments lie, just not about the shape of the Earth. Is that what I can take away from that?
Not everyone always tells the truth about everything, but the shape of the Earth is not something
Brother.
that anyone is lying about apart from flat earthers. Right? Because there is so many people that would have to keep that secret. It is mathematically impossible. All right? I have traveled the world. In the Navy,
disagree.
I've literally traveled the world. And when I was on surface ships, I had to do lots of stuff like with sextants on the bridge. When I was on submarines, I had to, we've got emergency engines that are powered by fuel in case something goes wrong with the reactor. And one of my jobs when I was training as an artificer was to calculate the fuel consumption over distances. So to say that if we were doing this journey and the nuclear engine packed in, we've got enough fuel so that we can get from A to B. And it was my job to do that. So if I got those calculations wrong, then we would have run out of fuel in an emergency situation, right? What did I base my calculations on? I based my distance calculations on the Earth being a globe. So my job literally depended on the Earth being a globe.
And how did you do that in your calculations?
I took into account the fact that the Earth has a radius. I took into account the known distances based on the Earth being a globe. And I knew how much fuel is consumed over distance. And I would calculate how much fuel was needed for a journey from A to B should the nuclear reactor pack in and we have to switch to emergency engines. I knew that the amount of diesel that the generators would eat up over that certain amount of time. And I would base those distances on the Earth being a globe. Again, it was part of my job.
No, I mean, I'm not discounting your job, man. I would never do that. Just if the radius is in contention in this
The
argument,
radius
well,
isn't
then
in
that's-
contention, though. We know what the radius
Well,
is.
in this argument, this debate, it is in contention because we're just not
Well,
buying
only because
it.
you guys ignore all the measurements.
Sticks and shadows and presumptions of parallel rays.
The parallel rays aren't
That doesn't do it
aren't a
for me.
presumption. We know that the rays coming from the sun are parallel. That's how sextants work. Sextants
I've
wouldn't
only
work
seen-
if the rays from the sun weren't parallel.
Dude, I see
Fuck me.
sundresses like all the time, man. Those are
So you see what?
crepuscular rays.
Crepuscular rays, yeah, they're parallel. It's just perspective makes them look spread out. And if you
So
notice,
how can you get an
yeah, wait,
accurate
if you notice,
measurement?
crepuscular rays actually change, the apparent angle that they have as you go past them, because
So with
it's
that,
perspective.
right? So the crepuscular rays, which are refracted parallel rays, those would not affect the angle of the stick that you're measuring.
No.
I disagree.
Okay, you can disagree all you want, doesn't make it right. The fact that we have measured the Earth so conclusively, we know what the radius is. It's not in contention. Right, do you know about the Tonga
disagree.
volcano eruption?
I'm sorry?
Do you know about the Tonga volcano eruption?
Oh yeah, the one that just happened?
Yeah. You know that kills
Yeah,
the
I
flat
heard
Earth?
about it. No, how so?
Pretty simply, right? All around the world, pressure waves from that explosion were detected, right? Completely. I'm going to get up a quick video from Geostriber. Which one is it? It's this one. So, yeah, so the Tonga eruption, pressure waves were registered all around the world from it, right? So this is where it happened, and every barometric pressure station around the world recorded that explosion. Now, say this is the point of the explosion, okay? This is the antipodal point, right? So opposite point of where the explosion happened. And say you're an observer here, all right? You would read two pressure waves. You would read one pressure wave going around this way, then you would read another, which would take slightly longer, going around this way, all right? And funnily enough, that is what happened with several of the stations. So, bring up the... There were several different stations that registered the shockwave twice, and the closer to the antipodal point that you got, the closer together the two shockwaves happened, right? And when you sum out the time it takes for the shockwaves to hit it, traveling at the speed of sound, and you sum out these two things, it always equals the circumference of the Earth that the shockwave had to travel to get to this point. There were several different stations that measured it, not just a few, like literally hundreds and hundreds. Let's go to Science It Out quick, because he's got a good video about it as well. So Science It Out actually took data from several different barometric stations around the world. These are showing you the different pressure readings that you've got. And he plotted them onto a flat Earth map. The explosion is here where the things are red. And then, so yellow is the closest, orange closest, yellow, green a bit further away, light blue furthest away, dark blue the furthest away. But on the flat Earth, it doesn't match, because if the explosion happened here and the Earth is flat, somehow the explosion was registered at the same time in both California, Golden CO, and Cancun in South America at the same time. Even though on the Earth being flat, this place is much further away from this place, so the pressure wave would have taken longer to travel. South Africa in general is a massive problem. Because
okay, I don't subscribe to this map, just for the record. I'm more of a
any flat map,
moon
any
type
flat
of
map
guy.
has the same issue. That's the thing.
No, but on the plasma moon map, check it out. You can look it up. North America and South America would pretty much be parallel to each other.
Yeah,
So
it would
they
still
really
wouldn't work out.
They would register about the same time.
It still wouldn't work out, because Africa is still opposite on that point, right? And Africa is a big issue, because Africa seemed to have the pressure wave hit it all around at roughly the same time. However, if you map all of these times onto the globe, it actually matches the pressure wave going out in a circle around the globe. Red closest, orange a bit further away, yellow a bit further away, and it matches what we would expect on a globe. The only way that you can make all the barometric readings from the stations all around the world work is if you map them onto a globe. Otherwise, they don't make sense. McMurdo Station in Antarctica received it around about the same time as this area in Melbourne. Hong Kong received it at the same time as San Carlos, which would be completely opposite sides of any kind of flat Earth map. Also, the moon isn't plasma. That was really dumb. We'll get to that. So there is no explanation for where the pressure waves are registered on a flat Earth. The only way that it matches reality is if you say that reality is a globe. And also, like the first one I showed you with the fact that there is two pressure waves, one shorter, one longer, depending on where you are from the antipodal point. That would be completely impossible if the Earth was flat, because you wouldn't get pressure waves going round in a circle and hitting it twice. You would get them reflecting off of everything. So this explosion, however devastating it was, is even more devastating to the flat Earth.
Okay, but like you can agree that if the Earth wasn't what we're assuming that it is, there could be other factors in play that could cause this to happen. Anything is possible,
like
right?
what? I mean, you're just saying, oh, there could be some magic that makes this wrong.
Yeah, just because personally I don't know enough to debate it, but if there was something else acting upon, what's going on here, it could very well explain and give you the same outcome.
There is nothing in the known universe, physics-wise, that could explain that if the Earth was flat. It matches the globe model perfectly. Why is that?
Well, I mean, just like what you just said, I mean, all of the studies and in science are all wrapped around the heliocentric model currently in mainstream. So
yeah, that's because it's been tested. That's what science does. With science, the aim is to falsify something. The globe Earth has never been falsified.
I would disagree.
Tell me when it was. Tell me when the globe Earth was falsified, then.
I mean, we can see too far. I mean,
no, we can't see too
the
far. We see how far.
That's really what it comes down to with me, man.
What it comes down to is you not understanding refraction, isn't it? Yes.
No, not at all.
Yeah, it is. You don't understand refraction, therefore the Earth is flat.
No, I know. I see refraction, miraging. I understand what's going on.
Why do you trust
your eyes? It's not lifting things up at different elevations.
Wait, why do you trust your eyes? They're awful. You know your eyes see everything upside down, right?
Well, that's how you view your reality. So
you view reality upside down, really?
No, through my eyes.
Yeah, but your eyes see everything upside down. That's a bit rubbish, isn't it?
Well, I mean, to tell me not to trust my eyes is a little rubbish.
Well, no, you really shouldn't trust your eyes. Please use your eyes to detect ultraviolet radiation that's going to hurt you.
Okay, can we I can go back and forth on refraction more if you would like, but
well, no, you obviously don't understand it. So there's very little
sun.
Point. Well, how about you try and explain one of observations that I used first?
No, I get it, man. Like refraction is something completely different, in your worldview than mine, and it could go either way.
Only one of them is based on reality. Yours is based on a misunderstanding of refraction.
Not at all.
Yeah, absolutely. According to
all of the refraction that I have seen is inferior mirages on the water.
Well, that's because you don't understand refraction, obviously.
And the only one that you've shown me
all of the world's experts, you don't understand refraction. So again, you are claiming that with your very limited knowledge, you're claiming with your very limited knowledge that you know more than all of the world's experts. You are a very, very expert, yes?
I'll take that title.
Yep, he's just admitted he's very, very, very expert.
Man,
you are a carpenter, right?
Bro, this isn't even a debate, man.
Wait, so
open your eyes. So if you trust that someone's telling you that there's not a geometrical horizon there, it's there, but you just can't see it. Refraction is causing you to see it.
Yeah, as I explained, you don't ever see anything as it is. Wait, you said that you're a carpenter, right?
Yeah.
So what do you use for measurements? Do you use your eyes?
I mean, we use our eyes for design. Like, that's reality. We
No,
make sure
for
that the
measurement.
project looks good with our eyes.
I'm not
That's
talking about
reality.
design. I'm asking you for your measurements. When you use measurements, what do you use? Do you use your eyes, or do you use a tool designed to measure?
Yeah, I use my eyes. I read my measurement with my eyes.
No. Are you using your eyes to make the measurement?
That's how
or
I see the measurement.
Are you using your
I see the
eyes to make the
measurement with my
measurement, or are
eyes.
you using a tool to make the measurement?
Yeah, my eyes are the tool. I
No,
view the measurement.
your eyes
and
are
and
not a tool to measure.
Oh, they're not.
What are you using? Are you using a tape measure? Are you using a right angle? Are you using things
Craig,
that you
that's
have
a dumb
to
question. You know, like, yes.
just
of
answer
course
the
we
question
use
then.
tools
What
to
do you
measure.
use to take a measurement?
Like, you know what it is, bro. It's a measuring tape. Like,
Right,
come
so
on,
you
let's get
don't
to the
use
point.
your eyes to measure then. So why don't you trust
was
your
being
eyes to make that
yes.
measurement? Why don't you just trust? Why do you need the measuring tape at all? Why don't you just trust your eyes?
So we can just get out a measuring tape and measure the refraction.
There's
that what you're
no
saying?
measuring. No, I'm saying that there's tools that are
Okay,
available
these are
for measuring.
completely. Yeah,
There are
these
tools
completely
that
irrelevant.
allow you to do the measuring. Just like you as a carpenter, you don't use your eyes to measure. You use a tool. Just like when you're trying to measure the earth, you don't use your eyes, you use a tool, you tool.
Right, and I ask you, what tool can we use to verify that holograms are being elevated from
No one said
behind a physical
holograms.
barrier?
That's not what a hologram is.
Okay, well, I'm going to call it a hologram based off.
That
what
means you
you're
don't understand
describing.
holograms. You do not get to redefine what a hologram is. So was it a hologram earlier that I showed you with the thing lifting up from the can? Was that a hologram?
No, that was atmospheric compression.
That was atmospheric compression that lifted something up from behind the horizon.
I mean, that's not what I said. You want things to be lifted up from behind the
I
horizon.
literally showed
don't.
you it being lifted up from behind the horizon. You are not owing as hard as you fucking can right now.
Bro, that's what you take away from that observation. I see something completely different.
You must have been looking at something different.
If you want
then,
to
fucking
pretend that
moron.
things are being lifted up,
I
and
showed you it being
embarrassing-
lifted up from behind the horizon. I literally showed it to you. The thing that was behind the horizon got lifted up from behind the horizon. It's simple. Just like you.
Simple, man. Gotta keep it simple.
So, let's have a look at this. How do you remove refraction? Well, you go high. You go up high, you don't get much refraction because you're away from the large difference in temperature and density above the water. So what do? You go 210 meters above sea level, like with this picture. 210 meters above sea level, which just also happens to be the same height as that middle pillar on the Forth Road Bridge there. So you've got a line of sight. You've got a tangent, right? From your eye, which is 210 meters, to the top of that bridge. A tangent, which is hardly affected at all by refraction because the refractive conditions at 210 meters are very minimal, right? So, would you agree that both your eye and that red line is a tangent of 210 meters?
I can't verify any of that, but I'll take your word for it.
Based on what I've just told you, would you agree that your eye and that red line is a tangent of 210 meters? Do you agree with the premise, yes or no?
I mean, yeah, for this example, sure.
Right, cool.
But like I said, I can't verify that. So
I mean, you could go here yourself and do the same observation if you wanted to verify.
Okay,
it.
great.
But,
Let's
he
move
did
on.
a video. This is from a video where he's looking at the marker that shows where they are, and he does 360 spin. But right, so we agree that eye height is a tangent to the top of that bridge, which is 210 meters. Okay, so anything, if the Earth is flat, that is in line with that tangent will be 210 meters. Correct?
Sure.
Right. Those hills in the background are about 40 miles east of Edinburgh. The hill directly behind that middle tower is 507 meters above sea level. 507 meters above sea level. You just agreed with me that anything that is 210 meters, if the Earth is flat, would be tangent to that red line and your eye level. that means that 210 meters on that mountain would be about halfway up that mountain. But however, the entire mountain is hidden
and this is where we
below that red line, right?
So if that is true,
let me finish. Let me finish. So if, as you agreed, your eye and the top of that tower form a tangent of 210 meters, how does the flat Earth explain that over half of those mountains is being hidden and actually falls below that tangent line?
All right, we just want to hop back into like perspective here and converging lines, and you know.
Oh, perspective would never make anything go below that 210 meters because, as you would agree, perspective makes what's below rise up and what's above
like if
go
you're
down. So it would never, ever go below that red line if that is your tangent eye line. Parallel lines
things don't
do
get
not
smaller
intersect.
as they go further away from
Absolutely,
you.
they get smaller, but they do not go below the eye line. They get smaller into what is your line of sight, but they never drop below it. If the Earth was flat, the further away those mountains got, they would get smaller and smaller and smaller, but be above that red line always. Always. That is what perspective tells us would happen. They would never, ever, ever drop below that red line at the 210 meter point. No matter what, no matter how far in the distance, that 210 meter point up that mountain would match that red line if the Earth was flat. It would get smaller in totality, but never drop down below eye level.
Right, so in my position is like, you know, street lights. When you see a row of them, they go lower and lower and lower, and eventually they go below your eyesight into the, you know, converging horizon.
No, they
so that's,
a line of if you have a perfectly flat and level line of street lights, they would never drop below your eye level. They would never do that.
And as far as I know, the cameras could be way below, you know, sea level from the tower's point of view. I mean,
it's not the camera.
Anything could be going on.
The camera's 210 meters, the same as that tower.
Like I said, man, it's perspective for me.
Yeah, perspective doesn't answer it.
I can do simple. I can do simple.
Perspective is alpha equals 2 times the arc tan of g over 2r. That's how to calculate angular perspective. All right. Nothing about that says that it would drop below that red line. Anything that is 210 meters will always be in line with that red line, never ever below it. It will get smaller and shrink into that red line, but never drop below it. Flat Earth cannot explain how that mountain is below the red line, because that's not how perspective works.
So how does refraction play a part?
Again, you're 210 meters above the ground. The refractive effects are minimal, practically zero.
Yeah, I would disagree.
I started with that.
Okay, I mean, I would disagree. There's always refraction.
Yeah, so minimal though. There's absolutely
that was
minimal.
Your statement.
Again.
So, okay, but there is refraction. So
yeah,
at those
minimal.
distances,
like it's going to cause like
the mountain could be compressed.
It's going to cause such minimal
and,
difference that it's not going to make a difference to what you see. Refraction will not cause that at this height because there is not enough density and temperature change in the atmosphere over that distance.
Yeah, I mean, this just isn't really a valid.
It's absolutely valid. You not understanding perspective is your problem here.
It's not, man. I mean, just the simple, black swan photo. I mean, it does. That's really where we should be arguing. Because this right here,
nothing about perspective answers this. Nothing at all.
Yeah, I mean, this doesn't do anything, man.
It should, because it completely destroys the flat Earth.
No, I mean, our argument is perspective, atmospheric refraction.
Yeah, perspective doesn't
so.
act the way you say it does. There's nothing about perspective that agrees with you. Nothing at all.
And most definitely there's refraction going on here. Do you see the
again, you're 210 meters above sea level. Refraction is going to be minimal at your tangent. Absolutely minimal. Like practically zero.
If we can't trust our eyes, then we can't prove that this isn't flat Earth. I mean,
the measurements here.
It's an observation.
Yep, and it's an observation that you can kind of make measurements from, right?
I mean, yeah, but you're making measurements based off your observation. So
yeah. So we've got a reference point as to what things should look like, and they don't. It matches the globe, not the flat Earth.
Well, whenever we say that, you guys are like, no, it's what we're saying because of refraction. So, like I said, man, it's not.
Yeah, again, no observation that you guys make.
The argument could go back and
forth
till the end of time, which it probably
Nothing
will,
that you guys make is 210 meters above sea level. So you're just ignoring the Tonga explosion. You're ignoring the fact that this clearly shows that the Earth is curved. You're ignoring the measurements of the Earth's radius. You're ignoring the measurements of the Earth's rotation. You're ignoring the fact that you yourself could measure the Earth's rotation. It's very fucking easy. You're just going to go, no, there could be something else causing that, when there is nothing else that could cause the measurements that we get. Like, for instance, the aether was debunked many, many years ago, over a century ago. There is no electromagnetism that can affect light in a gyroscope like the one Bob used. It measures the Earth's rotation because the Earth is rotating in 3 axes, which means it's a sphere.
Yo, can I show you this video real quick? Let's see what you think about it.
Sure, go ahead.
Just pick your brain a little bit. All right. This is one
Whenever you're ready.
You may have already seen it, but it's by the Plain Truth.
Oh,
it's just
God.
something as simple as this will show you
Yeah.
how things can be hidden behind, you know, a band of refraction
Sorry, give me 1 sec.
and kind of simulate a curve.
171. Okay, you're up.
And this is just the camera turned sideways on a brick wall, which we know is flat.
How do we know it's flat? Where's the measurements?
Where's the measurements? Come on, Craig, you're desperate, man.
Well, no, if you're going to make a claim that it's flat, I would like to see measurements to confirm that. How did he determine it was flat?
Oh, well, masons don't build curved brick walls. Not like this. I mean, it would be.
I mean, but how can we confirm
He
that?
shows it right here. I mean, is that a curved brick wall? And
I
look at
don't
the
know.
converging lines.
Where's the measurements?
You really need measurements, Craig? Like you
Well, yeah,
can't tell
measurements
that's a
are how
flat
we
wall?
determine things. I'm not just going to look at something and go, that's flat. But anyway,
Oh
carry on
my
with your
gosh.
point.
Okay, but yes, you
him,
can see,
you know, moving it
the
below
refraction
the
on this
point.
one hides the wall behind it.
So please do tell me at what point we have 9/10 of our eyes underneath the ground when we're looking at things.
I mean, he's just getting eye level with
No,
the
he's
brick
not
layer.
getting
You
eye
can still see
level.
the bricks
Half of
right
his
there.
eyes are under in it. Well, 3/4 of his eyes
Half
right
of his
now are under.
eyes?
Yeah, right now about 3/4 of his eyes are underneath what would be the ground. When do we have
I mean, he's
3/4 of
literally-
our eyes underneath the ground? Just out of interest.
Well, I mean, as the horizon rises to eye level, I mean, that's the
The
same.
horizon doesn't
pretty
rise to
much
eye
the
level.
same
We
viewing
went
height.
over that.
Well, I mean, that's your position.
Well,
not
no, it's a
mine,
fact
but-
that the use of a sextant shows that the horizon doesn't rise to eye level.
Okay, but he's showing here, like, refraction, it can make things look like they're on the other side of a so-called curve. So
Yeah. Okay. So that again, that's refraction.
So
off
your
of a-
your position
that's
is that
refraction
that
off
wall
of a
could
hot
be
thing that is emitting, heat on something we don't know if it's flat or not, and
Right, so
there's
nothing's being
there's
lifted.
no resemblance at all to what we would see over water. It's the opposite.
Okay, so you're
It's
saying
a
if
hot
this was-
thing, it's a hot
this was a-
thing, not a cold thing like water.
Right, so you would say that if this
Fuck
wall
me.
was cold and we did this experiment, things would be lifted above it?
It would
I'm
bend the
confused.
light in a different way, but again, this is not any. It's not flat. It's not on the floor. It's not over water like we would normally do an experiment for refraction. The density of the atmosphere on this is going to be going from left to right. I mean, is there any more ways that the plain truth can fuck up? Oh yeah, he also put 9/10 of his eyes underneath the ground. This is the worst attempt at showing how refraction works in reality ever.
Hey, so if these lines were to continue forever, would they stay parallel to each other, or would they
They-
eventually like converge together due to perspective?
They would never converge completely together, but the lines, if you look at that one in like just below the A, that line there, right? You see how that line goes along the whole way. The lines above it would never drop below it, and the lines below it would never go above it. right? You agree with that?
Right, but they would.
You agree with
Yeah,
that?
but I mean,
Yeah. Yeah,
eventually
so
they
it
would all
never
look
go
like
be-
they were one line.
Yeah, but it would never go below it, correct? The line above the line with the A on would never go below that line. Is that correct?
Well, it's never been my position that they would go below each other. It's
Right, if it never
so
go
they would all
below each
converge
other,
together.
then you can't explain the observation that I showed you, which shows that the line would go below it. You've just told me that convergence doesn't work the way that you say it does. This picture,
And like I said, in that
about,
observation, I mean, you're
this
completely
argument
ignoring
debunks
refraction
your
in that one to try to prove your point.
This
So,
observation debunks your argument about convergence that you just gave.
I disagree.
I disagree. That seems to be the mating call of the flat earther today.
Well, I mean, yeah, I'm not going to sit here and say I agree with something that I don't agree with.
I mean, you can
That's not what I
disagree with the
said.
facts that are in front of you all you want. It doesn't mean you're right. It just means you're being
You haven't
intellectually
you've given me
dishonest.
one piece of evidence this evening, and it's literally just been
I gave you way more than
whole-
one piece of evidence. I've shown you
whole
lots of
gas,
pieces of
which
evidence.
isn't even, is not
I've
even
shown you
present
lots of
over,
pieces of
over these
evidence.
observations.
Dude,
And then you're showing
I've shown you
a
lots of pieces of
drastic
evidence.
curved barrel,
I've
which
shown
isn't
you-
an ocean. It's not
I've shown
water,
you-
so that does
why are
nothing
you lying?
for me.
Why are you lying? I've shown you lots of pieces of evidence, not just one. Please don't lie. There's no need for you to lie.
I disagree.
Okay?
I reckon I'll disagree, man.
Well, that just means you're being intellectually dishonest on purpose. You are being willfully ignorant on purpose. That makes you a fucking moron.
Oh, you can feel that way. That's fine.
It's how I do feel, because flat earthers are all fucking morons. Because they can't ever present evidence for their nonsense. Only misunderstandings of basic physics. And hand wave away
Anybody can
all
look
the
into
stuff that
this?
disagrees with you. Anyone that actually looks into it with any modicum of intelligence knows that the Earth isn't flat. I've been looking into it constantly for about 5 years, and I have discovered a million ways that it's impossible for the Earth to be flat. Because you know what?
Geometric
I actually
horizon,
understand
you just
physics.
can't see it. Got it.
Again, you want
The curve is there, you just can't see
it. Is refraction a
Got
thing?
it.
Yes or no? Is
Well,
refraction a thing?
refraction works for you in certain
Refraction a
arguments,
thing?
and then you
Yes or
completely ignore it in
I'm asking
other
you a question.
ones.
Is refraction a thing? Yes or no?
Absolutely. That's
Then,
been my whole
if
debate.
refraction is a thing, do we see the geometric horizon? Yes or no?
That's a question for you.
No. It's a question for you. If refraction is a thing, would we see the geometric horizon? Yes or no?
That's not my position. The horizon is apparent.
It's a
where the
yes
sky
or no
meets the-
question. If refraction is a thing, would we see a geometric horizon? Yes or no?
Craig, do we ever see the geometric
It's
horizon?
a yes
Will I
or no
ever-
question. Can you answer
I know.
just
I'm asking
yes
you
or
a yes
no?
or no question. Will we ever see it? Can you prove it
Well,
to me?
I've
please?
asked you. I've asked you the question, right?
You've poured cold gas over a freaking barrel.
Why
my
can't you
guy.
answer yes? It's a yes or no question. I just want you to answer one question. If refraction exists, which you've agreed, would we ever see a geometric horizon? Yes or no?
The horizon is apparent. Like that's my.
It's a
answer.
yes or no question. If
I don't
refraction
lay claim to a
exists,
geometric horizon. That's not a question for me.
It is. I just want a yes or no.
I'm not going to go.
Try and be honest
theoretical
and just
game.
give me a yes or no. If refraction is a thing, as you have admitted, would we ever be the Earth flat or a globe, see a geometric horizon of any kind? Yes or no?
Okay, so my whole life I've been told that the Earth is a sphere. I've
So
been
you
told
can't
yes.
answer. You can't answer a simple yes or no question.
What are you talking
because
about?
You know
Ever
it
since I looked into
destroys.
this,
You know it destroys your position.
I have been
you are
told
terrified
that there
to
is
answer
a-
yes or no because you know it
You're
destroys
asking me
your
a
position.
hypothetical question that I don't lay claim to, dude. So no,
It's a yes or no question. If refraction
all
exists,
of my education, all the
if you haven't had any
science tells you
education,
boats
don't
go
lie
over
to
a
me.
Physical horizon. They don't say they go into refraction or anything like that.
Just
So,
because you've never understood is your issue.
that's all I've been told. What else am I to believe?
Do you know what Snell's law is?
I mean, let's not get off topic here.
No, it's not off topic. That's to do with refraction. Do you know what Snell's law is? Yes or no? Oh, you don't like yes or no questions?
Snell's law. I've heard of it in y'all's debates. I haven't specifically looked
Yeah, it's to
into
do
it.
with refraction, and if you don't know what Snell's law is, you don't know anything about refraction. You are claiming you are the very, very expert on refraction. Yet you don't
I've never
even know.
claimed that. Why are you putting words in
Snell's...
my mouth?
You claimed that yourself. You said, "Yeah, I'll have that title."
Man, I was obviously joking. So.
But you claim that you know more than all the world's experts, so you must be a very, very, very expert, right?
Hey, look, man, is there a geometric horizon or not?
Yeah,
Like,
it's refracted.
that's all I need to know.
Of course, there's
Do
a geometric
boats,
horizon.
Are
We
boats
just...
hidden by it? Like,
Well,
please tell me, because I've been told that my whole life, and now
the boats are
you
hidden
and the Toon are
by
like,
the geometric
no,
horizon.
There's no geometric
Listen, you want to answer
horizon
to your question or not, dipshit? Boats are hidden by the geometric horizon, but the geometric horizon is refracted. Does that answer
You don't
your
like
question?
this topic, do you?
I just answered your question.
Yeah,
see
but
how,
you're
see how that
triggered.
happens? When you ask
Like,
a question, I answer it. But when I ask you a
you
question,
see how when
avoid
Glovers
it.
get triggered, they start calling people names.
Oh no,
And
no,
I haven't
it's
called
not.
you a name.
Calling
this
you
whole debate.
calling you a fucking idiot isn't calling you a name. It's an accurate description.
Yeah, well, you're throwing insults because you've
No,
been
again, it's not
cornered,
an
I'm
insult.
Sure, so.
It is an accurate description.
You can't show me a geometric horizon anymore, so you're on the
Absolutely,
fence.
I can't show
it,
you a
dude.
geometric horizon because there's refraction. I can't show you
Well,
anything.
just a few years ago, it was all about a geometric horizon. Boats went over it.
Are you talking to someone a few years ago, or are you talking to me right now?
Okay, well, you're asking me about my experience and like the things that
No,
I know.
I'm
Like,
telling you the
should I
facts
see a
about how it
geometric
is, and you're
horizon?
wrong.
Well, based off of what I've been told, right? Yes,
Maybe you've
boats
never
go over
listened.
it. What do you mean I never listened? That's what we were all told. You know
Because
that.
you've obviously never realized that refraction would mean you never, ever, 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 ever see a geometric horizon. If there is an atmosphere, you will never see a geometric horizon.
Since people started looking into this, that's very
No, it's not convenient. That's always been the
it.
case. That's always been the case.
So we were never told boats go over a physical horizon.
We were just told boats go over a
miles away, there's
horizon.
physical
We were just
tangent
told boats go
horizon.
over a horizon. That's it.
Right.
Yeah. Again, you're not arguing with other people 3 years ago. You're arguing with me right now. And I am telling you that we will never see a geometric horizon because we have an atmosphere. You will never see anything as it is because light has to travel from the thing you're looking
But
at
you'll
to
sit here
your
and
eyes.
tell me. But you'll sit here and tell me that a mountain is below eye level, so therefore the Earth is curved.
Because that is an observation
Come on,
that can't
man.
be
Like, what are
explained
you
by the flat
doing?
Earth. That's an observation that can't be explained by the flat Earth, by refraction or anything.
Already
There's no
explained it,
refraction
dude.
at 210 meters above sea level.
Yeah, I
that would
haven't
cause
explained
500
it.
meters of a
Other
mountain to
experienced flat
disappear.
earthers have explained it.
No
and
flat earthers
that's
ever
why
explained
The
it.
flat earthers are growing. I mean, it's
No,
it's a reality, man.
Flat Earth isn't growing. Who told you that nonsense?
100%, bro. You know how many people have just showed in
Dude,
the
flat
past
Earth
like
is
8
not
months?
growing. If you search for flat Earth on Google Trends,
Yo.
more people search Bigfoot than flat Earth.
So how do you feel about the local sun, man?
The sun isn't local. It's been measured.
So like seasons are caused by the tilt of the Earth, right? Like what
Correct.
David says, and it made perfect sense. So like the angle of the rays is what gives us our heat. So
the amount
on
of
high
the amount
winters,
of light over
our
a
high
certain...
winter sun in the inner north, like when it's high in the sky, man, like I can barely feel it, right? At its highest point. But in the summertime, when it boom, as soon as it hits the horizon and we're 3 million miles away further, man, I can feel that sun burning. That's a local sun, dude.
No, the sun's not local because we've measured it how far away it is.
Like I
And
said,
what
my
happens with what
experiences-
happens with the seasons is what we expect to happen.
Just think about it, y'all.
With the Earth tilting away from the sun, it's what we expect. It means that more of in the winter in the northern hemisphere when it's tilting away from the sun, that's the same amount of light over a larger area. But there's an explanation for the mechanism behind it all. On flat Earth, all right, for the winter and the sun to be different, the sun would have to be further away during the winter. What is causing the sun? What force is causing the sun to change its acceleration and movement so drastically throughout the year? How, in fact,
I
how
don't
is
know,
the
bro,
sun
but
even
we need to
stay-
figure it out,
if the sun is small and local, what is even keeping it up in the air?
I don't know, man. That's what we need to study.
Yeah, we
Because,
studied it.
The big ball
the
of
Parker Soda
hydrogen
probe,
92 million miles away just ain't
the
cutting
Parker
it. We
Soda
can see
probe.
clouds behind the sun, my
We
guy.
can't see clouds behind the sun. The Parker Soda
Can
probe.
I share my screen?
Wait, the Parker Soda probe went to the sun and literally went inside the star's coronosphere. It measured how far away the sun was. So
I don't appeal to authority. Can I share my screen? I would
it's
like to
not an
show
authority.
clouds behind the
It's a
sun.
fact. Yeah, you can share your screen. You're going to show a thin cloud with glare coming through it, aren't you? I'm making a prediction right now. Everyone, there's my prediction. He's going to show some thick and thin clouds with the sun appearing to shine through the thin cloud. Tommy, could you please send me the images of the sun shining through the real
Can you
stuff?
verify how thin those clouds are, please?
Yeah, well, you have thicker and thinner clouds. That's what happens.
Can you measure those clouds for me, please?
Yeah, can you measure the sun inside those clouds, please? I can show you the sun apparently shining through.
I'm not claiming the sun is physical and that it's measurable.
It absolutely is. Okay, here we go. So if the sun is shining through those clouds, if the sun is literally, behind those, in front of those clouds because you say it's shining through, then can you explain this for me? Let me get it out. Thanks, Tommy, by the way. Here we go. Right, so tell me what is happening here. Is the sun in front of this pole?
What pole? I can't make out a pole.
The big wooden pole in the center of the screen. Is the sun behind?
Yeah, I mean,
that?
I can't verify that that's a pole. I don't know what it is. I can't. Is there measurements on this pole?
It's a big wooden thing that's connected. Yet the sun appears to be shining through it.
Yeah, I mean, that could just be like editing or something on this picture. I
no,
can't
it's not. It's just a
verify
picture taken.
pole, but...
Oh my!
What is this? What is this supposed to do for me, Craig? I don't get it.
Well, is the sun in front of it? Yes or no? Is the sun in front of that pole? Yes or no?
I don't see the sun. I just see glare.
Oh, really? You just see glare? So is it maybe the glare that's making the sun appear to be in front of that?
Okay, but this is nothing, man.
Is the sun in front of that pole? Yes or no? Here's the image from a bit further away.
I'm looking at a glared picture.
You can quite clearly see that it's like a telephone wire pole or something, right? Is the sun in front of or behind that pole?
Like, of course it's behind it.
Well, why does it appear to be in front of it then?
It doesn't appear to be in front of it.
Well, it absolutely does. I can literally see the sun in front of the pole.
What? Man, if you're using this as an example, dude, it's like...
Well, where... Are you telling me you can't see the sun in front of that pole there? Where's the pole? Where's the middle of the pole? Where's it gone? Let's zoom in on that and have a bit of a better look. Can you tell me where the pole's gone? Tell me when you see the pole.
Okay, can you put the same type of filter?
Wait, just let me know.
We just had on that other example on this picture.
It's the same one. Just let me know. What this is zoomed in as much as I
can.
Well,
we had one with a filter. So
wait, this is zoomed in.
I don't even know what type of filter that was.
Again,
either.
this is zoomed in as much as I can. Where's the pole? Where is it?
Where's the pole?
Yeah, where's the pole? Because I can see the sun in front of it there.
Dude, this is a blown out shot of the sun. Like,
so it's
what are you talking
glare.
about? This is
so
not even comparable to.
It appears
to
to be in front of that
you.
pole, even though it's not in front of the pole. Is that what you're saying? Is that right?
I never said that. I never said that.
But it does appear to be in front of the pole.
It's
because I can't
out
see
a
the pole.
portion of that pole. I get what you're saying.
Right. So
It's blowing out the camera lens. Yeah.
yeah, exactly, and that's exactly what happens with the ones that you show of the sun apparently with clouds behind it.
Absolutely not.
Oh,
That's
right.
what you want it
So
to do,
your
but it's
special
not.
plead, what you're doing right now is a fallacy of special pleading. Oh no, that happens, but it doesn't happen in my circumstance. That is a fallacy of special
I didn't
pleading.
show you a blown out picture of a freaking light pole, dude.
No, you showed me a blown out picture of the clouds in the sun. The sun
Yeah,
and the
so
clouds.
you
rather.
show me one where that's not what's happening with the clouds. Don't use something completely different like a telephone pole.
I can show you many pictures of the clouds of the sun not in the clouds, because it doesn't happen. You put a solar filter on it, and it will never ever happen.
Because it's a solar filter.
Yeah. So with a solar filter, the sun will not appear to be in front of the clouds. So how does the solar filter magically bring the clouds in front of the sun?
I mean, you tell me how thin those clouds are compared to the ones in front of them. You might have
Pretty
something,
thin.
okay? But
There's different types of clouds.
pretty thin. Gotcha.
Yeah. There's different types of clouds.
Yeah, nice.
But why is it with a solar filter, none of those clouds will appear to be behind the sun? None of them. Hey?
Yeah, I mean, it's a lot closer than what you say it is. So.
Well, measurements again disagree with you.
Just my example of like the sun at high noon in the winter compared to sunrise in the summer. That makes no sense. Being as far further away from the sun versus winter and summer.
What makes no sense?
The high angle of the sun in the winter, not even being able to feel it.
It makes perfect sense with
and
the
then
globe model.
being further away in the summer, and as soon as it hits the horizon, I can feel the heat.
Yeah, it makes perfect
But I'm
sense. On the
further
globe model.
away from it at a lower angle. Come on.
How about explain this picture to me then?
You're not. There's nothing you can do to try to
Explain
to me how
this
that's
picture to me.
even
I mean,
possible
you
on
not
your
understanding
ball
how
model.
seasons work is kind of you. That's a you issue. But go and explain this picture to me, would you? Where's the sun?
I don't know. I wasn't there. I didn't do the observation. I'm just looking at a picture,
Pseudoscience
man.
again. It doesn't count unless I did it myself. Is that what you got? Pseudoscience and lies?
Well, I'm just saying you're asking me to explain it. So
Well, you were asking me to explain the pictures that you didn't take. All right? From now on, for the rest of this debate, you are only allowed me to show me things that you have specifically done yourself. How about that? So can I see your specific experiments that have debunked gravity, please?
debunk gravity.
Yeah, you were saying that gravity isn't real earlier.
I'm just saying that I never said gravity wasn't real. You guys just call it gravity and give it a special causation. From what
we've experimented to demonstrate what it is. So where's your experiments to demonstrate what you say gravity is?
I mean, obviously I haven't done any, but I don't. It doesn't make sense.
Right. So
to
you're
me
basing your
that this-
stuff.
hold on,
wait,
hold on.
Are you appealing to
Gravity,
authority?
mass
Are you
attracting
appealing
mass
to authority?
does not make sense to me because the sun can hold on to the Earth, right? But it doesn't affect the moon at all.
It does
the moon
affect
just
the moon.
stays perfectly in orbit. It doesn't tug on it just a
Yeah, it
little
does.
bit, right?
It absolutely does.
And then it holds
100%.
on to other planets just perfectly. It doesn't care about their moons.
It tugs on all of them perfectly,
It can
exactly as
hold
it should.
down oceans. This force can hold down oceans of waters, but we can walk around.
Yet that's because you don't understand what gravity is. Clearly,
No, I mean, you guys.
what
literally
you've just done is publicly explained that you don't understand gravity, therefore it's fake.
Dude, I've heard all of y'all's arguments, man.
Clearly not.
Pseudoscience.
If you've
bro.
heard, it's not pseudoscience at all because we actually experiment to try and falsify our claims, unlike flat Earth. So if you
Okay,
know
then
all
prove
about,
the
if you know all
causation
about gravity.
of your effect. Right
Yeah,
here
we've
for me.
done that
Prove
with
it.
the Eddington experiment of 1919, Cavendish experiment, the Pound-Repka experiment, the LIGO installations. There's countless experiments of gravity.
So you can show me space being warped and causing.
Yes,
mass
with
to
the
attract
Eddington
mass.
experiment of 1919, literally shows space being warped. The thing, you've never looked into it. If you know all about gravity, if you heard all our arguments, then please tell me what Newton's universal law of gravity is.
I'm looking at what you just said.
Wait, you said you know all about gravity. You know all our arguments. So please.
No, I didn't. I
tell
never
me.
said that, bro.
You just said I know all of your arguments, man. That was your fucking words just now. So tell me, what is Newton's law
you
of
just said that
universal
I said
gravity?
I knew everything about gravity. So chill, bro.
You said you know all our arguments, and a lot of our arguments include gravity. So if you know all of our arguments,
Yeah, and it's a lot of, from what I've seen, dude, it's a lot of...
Please tell me Newton's law of universal gravitational attraction.
Presupposing the nature of
No, we don't need to presuppose. We just do experiments.
Let your boy get educated.
No, you're just quoting your flat Earth little little mantras.
Well, you don't like
quotes.
that. I get it, bro. But just because I'm sitting here trying to
I
read
get
about
it, bro.
this experiment,
No, you don't get it, bro. You don't get
you're
it, bro.
You're getting upset. Like I don't need to look at it or something. Okay.
You don't understand at all.
You don't want me to look at it.
Don't tell me you get it, bro. When you don't get it, bro.
Well, I'm trying to get it, bro. So quit.
Well, stop listening to fucking con men then.
Well, how do I know you're not a con man?
Because I actually speak the truth and can demonstrate what I say with evidence.
But when the government tells me I'm spinning on a ball, but at the same time...
It's nothing to do with the government.
With a vaccine,
you don't need the government to demonstrate that the Earth is a rotating sphere. Don't push your untrustworthy nature onto other people.
What are you talking about? That's where it comes from. It's in government textbooks.
No, it's
not.
not.
It to me.
Government did not give me my textbooks. Well, technically I did because the Navy paid me to do my degree, but the textbooks weren't written by the government. I can tell that you've never been in higher education. You probably shouldn't be a carpenter either if you think your eyes are the best measuring tool.
I'm a carpenter. Like, how much education do you expect me to have? Okay, it doesn't take a genius to figure out you're not spinning. Okay, so...
Well, you're clearly not a genius because we are rotating. All of the evidence suggests that we are rotating. All of the measurements suggest we are rotating. Your nutter powers do not work here.
Yeah, I mean, this Eddington experiment is just all presupposing the gravitational fields. Dude, it's all presupposing.
Do you not know how you do experiments?
Nice.
With an experiment, you have to make a prediction from your hypothesis. You cannot make
a prediction
we can
see too far, man.
Listen. When you do an experiment, the experiment is based on a prediction from your hypothesis. You cannot do science without making an assumption. It is part of the scientific process for you to test because you are trying to falsify your hypothesis, and your hypothesis can be a guess about whatever you want. To quote Richard Feynman, what do we do first? We make a guess, right? And then we compute the consequences of that guess. And then we compare those computations to reality via experimentation. If it disagrees with experiment, then it is wrong. That is how you do science. The hypothesis of mass warping space-time was not falsified by the Eddington experiment in 1919. In fact, the hypothesis agreed with reality. It agreed with experimentation. To make an experiment valid, you have to assume to be able to make a prediction. Do you understand that?
Craig, does the atmosphere spin with the Earth?
So you just ignored everything that I said, right?
Yeah, dude, I'm not going to go back and forth all day. I don't agree. So
you don't agree with
you
how
can sit here and
science
say that I don't understand and
you
all
don't
that. All
wait,
you
wait.
want,
You
bro,
don't agree with how science is done.
I get it.
Are you saying you don't agree with how science is done?
Yes, I do agree, man. Just like I said.
So you like pseudoscience then, do you?
You do, bro.
No. I follow the scientific method. I follow what Richard Feynman says. I follow what Sir Richard Francis Bacon said when he came up with the scientific method. I don't do pseudoscience. I actually follow science. You just dismissed science. You love pseudoscience. That's all you've got.
Yeah, you can say that all you like, man.
It's a fact.
I can see Stone Mountain from Kennesaw, and it's not distorted, so
yeah,
Earth is flat.
And have you done the calculations to see what you should see?
I have. We're at the same sea level elevation.
And have you done the calculations to see how much of the mountain you should be based on your eye height?
100%.
Can I see those calculations then?
Yeah, go to the Earth curvature calculator and
No, no, I'd like to see your analysis
punch in
of
the
it.
observer's height.
No,
the amount of obstruction
Your
that should
standard
be
of evidence
taking
was
place.
it doesn't matter unless you've done it personally. So can I see your analysis of how much of that mountain you're talking about you should see, please?
Well, unfortunately, I don't have a camera or anything, but anybody could just find an observation point
But
like
you
I
said
just
it doesn't
did,
matter
or
unless
come
you've done it
to
yourself.
Georgia and you could go
So
to
I'd like to see your
Stone
analysis.
Hospital and look at Stone Mountain.
I'll tell you what, I'll put up your
away.
screen. I'll put up your screen and you can show us that analysis, okay? So over to you.
Well, like I said, I work full time, man. I haven't had time to do
it's
that.
all right.
Like I said,
I'm sure that's your biggest proof.
I saw this when I was at the hospital when my daughter was born.
I'm sure if that's your
okay?
biggest proof, dude.
But there's other observations anybody could go
hold on,
There's
hold on,
plenty of
Hillside,
channels
Hillside, hold
where
on,
people have
chill.
done the same thing.
I'm sure
so.
if that is your biggest proof, then you're going to have an analysis for us. So, you know, over to you. Please, you know, show us the analysis of your greatest proof of seeing this mountain that you keep bringing up.
Okay, go on Google, look up the
No, you're not me. I'm not doing your work for you.
No, if you don't want to do the work,
analysis.
though, that's fine. I'm telling you how to do the work.
No, you can show
Okay?
it. You can
do the
show
work,
your screen
or you
and
don't
you can
have
show
to.
your
I'm
analysis.
not here to hand it to you on a silver platter. Other people have already done that.
This is how debates work. You make a claim and then you show your evidence. I'm not
You
showing
can go
your
down this
evidence
claim
for
route
you.
like McToon
You
did,
please
dude.
now
It's-
present
it's-
your
it's
analysis
laughable,
of your
bro.
claim. Over to you. Go on. I'm waiting.
Over to you. Go on. No, I'm
Yep,
telling you.
I'm gonna load a bong
You
whilst
could
I'm
go
waiting
on
for you.
Google. You could find.
Yeah. Whilst I'm waiting for you to show that evidence, I'm just gonna make myself a smoke.
Go to the Earth
whenever you're ready. Whenever you're ready.
Yours truly, Google.
Yep. So whenever you're ready, over to you.
Yep. So it's Kennesaw Hospital.
Yeah. No, I'm not doing your work for you. You can go. You can go and show us. So are you scared to show us? I might need to grind some more. Is that enough for a hit? Yeah, probably. So, yeah, whenever you're ready, you can show us that analysis.
I mean, I'm telling you, bro. There's no need to lie about it. Anybody can do it themselves.
I want to see your
You do it
evidence. So
yourself.
you've made the claim.
Oh, I'm
so
telling you, bro.
whenever
if
you're
you think
ready,
that I'm wrong, then disprove it.
well, I'm waiting to see your evidence. So over
I've
to you.
already given you the evidence.
No, you made a claim. Now you show evidence of that claim. Over to you.
And I'm telling you how to verify it.
Yeah, no, you now show me the evidence. Your standard was it doesn't matter unless you've done yourself. So let's see your evidence and your analysis
And
of
I've
that
done it
evidence.
myself, and
Over
I
to you.
encourage everyone else out there to go do it themselves.
Yeah, over to you. Go on then.
Nathan
Let's see.
Thompson, all of them have done all the measurements. They've handed it to y'all on a silver platter.
Yeah,
So,
we've
there
debunked
you
everything
go.
Nathan Thompson's ever done, but this is your claim.
Well, refraction.
So
I get it,
please
bro.
present
You
your
guys
evidence.
hold on to refraction for dear life, and you
So,
better.
any idea? Just when you're ready, I'm just gonna have a smoke.
Get you a smoke, brother.
So, are you ready with that analysis? Just whenever you're ready, the screen's yours.
Have you seen this one by Dirth, the Flat Earth Kitchen, kind of showing you convergence, how things.
Wait, you're changing subject now.
celestial
I
bodies
want to see
appear to
your
set.
analysis. Oh no, my keyboard's running out of power.
It's a good one.
Stop trying to change the subject. I want to see your analysis of your claim. So just whenever you're ready.
Yeah, look up the sea elevation of
Yeah, no,
those
no,
two
I'm not
points.
doing your job for you.
Go to the Earth
if-
curvature calculator.
if you could please
Oh,
present
you don't
your
wanna do the work?
evidence.
Well, then that's your problem, bro. If you're
Well,
going to sit
if
here
you
and
could
deny,
please present your evidence of your claim, that would be
What I'm
great.
saying,
It's
and
not
you
my
don't
job
even
to
wanna-
get your evidence for you.
dude. Okay, I'll go to Kennesaw, right? I'll shoot the video for you and I'll send it to you.
Yep, just
can
give me
see
the
all of
analysis.
Stone Mountain.
Wait. No, your claim. I'm just waiting to see evidence of your claim. So whenever you're ready, it's all yours. You're full screen right now. So over to you.
Yeah, I'm showing you like how celestial bodies right now.
You're,
They'll appear to set.
oh wait, so
Hand it to you on a silver platter, my guy.
you're not showing anything, actually. Did you think
Yeah,
you were
like,
screen
obviously,
sharing?
I don't
That's
have
hilarious.
the video, bro. I'm telling you though.
Yeah, cool. I'm telling
Like
you.
I said,
it's
if you
fair.
want me to, okay, then just dismiss it and we can move on. Otherwise, we're just.
Yeah, I disagree
this
with
is
what you say.
retarded.
Now, again, anyway, back to you presenting evidence for your claim. So it's all ready. It's all set up for you. I don't need to do anything. You can literally just share your screen now and show us that evidence. Whenever you're ready. I'll just grind some more while I'm waiting for you. So your full screen. Oh, have you left?
No, I'm here.
All right, cool. Are you ready to show that evidence?
Yeah, do you see my screen?
Yeah, no, this isn't the evidence of your claim. So if you could ignore Durf for now and present evidence
Well,
of your
you're
claim,
just
that'd be
ignoring me
wonderful.
when I tell you I didn't shoot that video. It was just a personal observation that I made.
Right, but surely you did an analysis that you can show us. Oh, nice of Durf to show the sun gets obstructed by
You want
something
a
physical.
citation and a stamp of approval on everything, don't you? You
Yeah,
can't
I
just
would
walk
like you
outside
to
and
demonstrate.
verify it for yourself.
So what Durf's
Like,
doing
come
here
on, bro,
is
this is a
showing that the
joke.
sun sets over a physical thing. That's very nice of him. Well done. That's very kind of him there.
Yeah, like, celestial objects would never appear to set is the argument that I've heard from the Glovers.
Not
So
when
he's showing it here.
he showed it being hidden by a
absolutely
physical horizon. Anyway, are you not going to show your analysis?
How many times are you gonna ask that question, bro? Like,
I'm just waiting.
is it not getting through to you?
Oh, what? So you don't have evidence for your claim? Okay, right. Cool. No worries. I'm going to dismiss your claim then.
Yeah, I'm sharing a personal observation that I made that anyone could do for themselves.
Yep.
I'm not hiding
as
anything.
As soon as you're able to present,
But you don't like
analysis,
that for some
that'd be fantastic.
reason. You don't like that at all.
Again, like in that video you're showing there, he's got the camera half hidden underneath the
Half hidden.
Yeah, half of the camera
You
is
see all of
underneath.
the table, bro.
Half of the camera is underneath the table.
He's getting down to where you would pretty much.
You would not have half your
would be
eyes
level with
hidden
the
under.
table.
Shut up. You would not have half your eyes hidden underneath the ground, which is what that camera is showing, right? And he's literally showing the sun going behind a physical object there. Right, here, I did a simulation.
Because guess what? A camera has like 3 or 4 inches up underneath it from where the lens is actually viewing from.
Yeah, no,
Hello?
you could literally
Hello?
see. You could literally see that half of it was
Bro.
half of what would be your eyes were underneath the ground. So if you want to watch this, is a simulation that I created.
Dude, that is childish, bro.
Yeah, Flat Earth is childish. You're right.
So he should just sit it 5 inches above the table.
Yeah, absolutely,
right?
because we never view
To
things.
simulate.
We never
terrestrial
view things from below the
Right.
ground. So yes. Anyway, if you want to look at the screen right now, this is a simulation I did. Okay, so I didn't assume any particular map. I just assumed a flat Earth with a sun about 3,000 miles above the surface of the Earth, which is roughly what Durf claims. Okay. So I made 4 cameras. As you can see, I've made 4 cameras, right? One camera looking at the sun directly, following it. One camera looking directly up at the sun. One camera to the side of it, and one camera above it, right? And I made the sun go across the entire length of the Earth. There's the cameras following it across the entire length of the Earth. This is, assuming it's about 3,000 miles up. And there we have it getting across the entire other side. Why didn't it set?
Craig, are you like serious right now with this?
Well, this is a representation of what you guys claim, yes.
So what am I like? Am I like a huge giant watching this model take place? Is that what's going on?
Technically. But
okay.
I've got a camera.
That's real realistic, right?
Right, listen.
Come on.
The top right camera is on the floor looking up at the sun. Right? That's what the top right camera is. So this is what you would see. The top right is what you would see if you were on the ground looking up at the sun. And
so is there any like atmospheric conditions added into this model?
I've removed atmospheric conditions in this model because
You better have.
Because
Yeah,
when you're looking straight up, the refractive effects are minimal. All right?
So whenever you watch clouds on the horizon, like they're not actually like on the ground.
Anyway, just tell me.
Right?
At
You
what
know
point,
they're still like 5-10 miles
so
up in the
just
air,
tell me
right?
at what point the sun sets on this flat Earth.
Tell me
whenever-
at what point do the clouds not, like, what are you talking about?
Yeah, clouds appear to touch the horizon because the Earth is curved. But in this flat Earth simulation, why did the Earth
you really
not
believe
set?
that, don't you?
In this flat Earth simulation, why did the sun not set?
In this flat Earth simulation, why is there no atmospheric conditions?
Just so we can see the sun clearly.
Why are you presupposing the nature of the sky?
Why didn't it set?
ask you a couple questions, Craig.
Yeah,
I gotta
I'm
know
asking
these
you a
before
question. You
I
can't
start answering
answer a question
questions
with a
about
question.
your model. So,
You can't answer a question with a question. All right, let's
can't answer
ask you a
question without
simpler
fully
question.
being informed about the model which
Let's
I'm being
ask you
questioned
a
about.
simpler question, right? Watch the sun in the top right. What happens to it? Just tell me.
Yo, this is childish, man. Like,
Just
we're
tell me
really
what happens
wasting
to the
people's
sun.
time, bro.
What happens to the sun? What's happened to it?
Yeah, I hope like people out there who like are on the fence like can see how ridiculous this is.
Yeah, people on the fence actually
To
messaged me
use-
after my debate with Bro Sanchez and said that they don't think Bro Sanchez is right anymore. Anyway, so what happened to the sun on the top right? What happened to it? I'll go back and forward. So look at the top right now.
Oh man, you
look
got
at it
me,
now.
bro. You got me with the 3D model, man. I'm back on the globe.
Just answer the question, right? What's the difference
Back on
between the
the
sun
globe.
now and now? What's the difference between the sun now and now? What's the difference?
What's the difference between a model with no atmospheric conditions and
What
refraction?
is the difference? I'm going to ask again. What is the
versus
difference
with
between the
atmospheric
sun now?
conditions and refraction?
What's the difference between the sun now and the sun now? What's the difference?
Put that on a solar filter.
Yeah, the amount of light coming from the sun is minimal in it. There's no glare or anything
Can you please
included
put that
in
on
the
a solar
simulation.
filter so we can see the true nature of the sun?
There's no glare or anything included in the simulation. Right? But what is the difference between the sun now and the sun now? Come on.
I'm not playing the kindergartner question game. Like,
So you're
so
scared
let's
to
look at
answer. You're
some
scared to
real-life
answer this question.
observations,
You're
and then we
scared to
can
answer
talk
this
about it.
question. Then are you?
Not scared. Why would I be scared to answer the question?
Because you
bro?
won't answer the question. It's a simple question, and you're scared to answer it.
Dude, I'm not playing kindergartner games.
Yeah,
with
because
you,
you're
bro.
scared to
This
answer
is
the
not
question.
a valid. This is not a valid.
It absolutely is
argument.
valid, and you're scared to answer the question.
Absolutely
I can
not.
feel you shaking.
Shaking in my boots, mate.
Yeah, absolutely,
No,
you
not,
are.
dude.
Yeah, and that's the worst attempt
Because
at a British accent I've ever
You're
heard.
trying to represent our world on a little map that doesn't even hold all of the variables in which we
Yeah,
are in.
in modeling, you remove extraneous variables for ease of modeling purposes. As
you better.
MC2 explained to you with all the NASA documents that you didn't understand.
I'm
Right,
trying to
I'll
understand,
answer the
so
question
take
for
it
you
easy.
because you're
Take
too
it
dense.
easy.
You're too dense to actually listen and answer the question. So I'll answer it for you.
Wait,
What's
you want
the
me to
di-
say
what
like
the
it got
difference-
smaller?
What
Is
the
that what you're
difference-
saying?
Yeah, well done. The sun got smaller between there and there, which is what would happen on a flat Earth. So why doesn't that happen in reality?
Okay, well it does, and then like you put a solar filter on it, and then it doesn't change. I get it, bro. But what I see with my own two eyes, oh, it does get smaller. There's plenty of
Right.
videos of that.
Yeah, but
the sun and
when
the moon
it
from
doesn't,
an
how do you
elevated
explain
point
why
of
it doesn't
view,
with us? Right,
the
you
sun
just
and the moon
admitted.
do not
you
go,
just-
do not eclipse the horizon. They get smaller as they move away.
No, they absolutely
Anybody
do
just go look it up. Look it up.
MC2
Watch the
literally
videos.
showed you the video of the sun half eclipsed by the horizon yesterday, or the other day. Don't lie to me. All right? But why? You just admitted with a solar filter the sun does not change in angular size. Why is that the case?
I mean, that's a good question. If we knew what the sun actually was
We do.
without
It's a
debating
nearly,
one
it's a
another,
nearly perfect sphere
right?
of plasma.
I think we could answer that question.
Yeah, we know what the sun is.
I think
We've sent
I
probes
think
there.
we assume what the sun is, but
No,
I don't
we
believe
literally
it. It's
sent- we
because
literally
Dirk,
sent
Dirk
probe
did
there.
an experiment where he had a light and a sheet, and the light was about 10 feet beyond it, and everyone in the room saw the light on the sheet from their own point of view.
Yeah,
And that's kind of how we view the sun. Because
again,
we try to
we've sent-
triangulate it.
we sent a probe there very recently, so you can't ignore that.
Appealing to authority. Next.
It's
I
not
don't
an appeal
believe
to
that.
authority. It's just something
Verify
that
that for
happens.
me. How do I verify that they sent a probe to the sun?
There's lots of radio transmissions from it. Why is radio transmissions from a physical thing funny? We got a video of it being inside the star's corona, looking out at the galaxy.
Just how like McToon said they bounce radio waves off the moon. Like,
Yeah, they absolutely have. I
okay,
bounce
that
lasers
doesn't
off
mean
the
that
moon.
it's a rock spinning in space.
People have stood
Just so
on it. It's
happens we only
definitely a
see
rock
one
in
side
space.
of it.
It's definitely a rock in space. People have stood on it.
Or is it made of cheese? You tell me.
No, I would have eaten it.
Me too.
But people have stood on it, so it's definitely a rock.
Well, you know, the pictures and the videos of the moon, that's a dull, dusty rock, bro. I saw it last night. I could read by it in my backyard. So if I got closer to that, I'm pretty sure it'd be too bright to stand on.
That's not how it works. How much sunlight do you think?
Not in your world.
No, in reality.
In my world, the closer
how much
I get to the
sunlight
light
does, you
source,
think, how much
it gets
sunlight do you
brighter.
think the moon reflects?
I don't believe it reflects
Well,
any
all
light.
right,
I
in the
believe it's
globe
its own
model,
light.
how much sunlight does the moon reflect?
Why are you asking me to speculate based, from the position?
Because
of
if
your
you're going to
model?
articulate something, you need to understand it. So, in the globe model, how much light is the moon supposed to reflect? This goes for your claim. If you don't know, you can just say, I don't know. That's fine.
Yeah, I mean, I don't believe that it's reflecting light. Just
Yes,
based off
but
what
your
I see,
argument
so-
is that if it was, it would be too bright when you got there. So, based on your argument and according to the globe model, how much light is the moon reflecting from the sun?
like measured in lumens.
No, just
Like, what
percentage.
do you mean?
What percentage of
Okay.
the sun's light is reflected by the moon?
I mean, you tell me.
Less than 1%, about 0.8% of the sun's light is reflected by the moon, okay? But that's the entire face of the moon that we see. Now, the entire face of the moon is 0.8% of the sun's light reflected. If you were standing on a very small portion of the moon, what percentage of the sun's light do you think that very small portion of the moon would be reflecting? A
Well,
lot
first
less
of all,
than
I'd like to
0.8%,
verify-
right?
Right. First of all, we got to back up and verify that the moon is actually reflecting sunlight. So
Yeah, anything
how do
reflects
we
light.
verify that?
Because everything reflects light, that's how we see it.
But some things are just their own light source.
The moon's definitely not
Flashlight's
its own light source.
reflecting
Craters
light,
have
It's
shadows.
its own light. I'm sorry?
Craters have their own shadows. The moon doesn't reflect its own light source.
Yeah, and like all the craters on the moon, Craig, they're like all 90 degrees. Is that because of gravity?
And that's because of explosions.
So nothing hits it like at a 45-degree angle?
Yeah, even if it does hit it in a 45-degree angle, it's the energy from the explosion. They're not usually crashing straight into it. They're usually exploding as they get very close or exploding on the surface. And it's the explosion that creates a crater, not the actual impact. I'm going to bring
So would you agree that the moon could just be a plasma event? That
No, I
takes
would not
place
agree
in
that the moon is
Krypton
plasma.
gases,
We have bounced stuff off it. We know
in the
exactly what it
Krypton
is.
gases and the
People have
Krypton
also
gases
been
in the
there.
upper atmosphere?
People have been to the moon. We know it's not plasma.
How do you know they've been there?
Because they
Somebody told
recorded
you?
everything when they went there.
That could have just been a movie, though, right?
It
Could have been.
No, it
like,
couldn't have been.
Speculate with me.
It couldn't have
Speculate
been a
with
movie.
me like I want to do.
It couldn't have been a
you want me to
movie
speculate
based on
with
the
you.
technology at the time. It would have cost more to fake it than actually do it. Slow motion cameras at the time disproved the notion of that being recorded.
Did you see the moon lander?
Yeah,
Like, it was like a tent, bro.
it was
You
covered
buy
in a
that?
bunch of foil to help reflect radiation. That wasn't what was underneath.
Damn, you really believe they went to the moon?
Well, they did.
No, you believe it. You weren't
No,
there.
they
You
did. The
can't
evidence shows
verify
that they
it.
did.
No, that's. I mean, a movie doesn't prove that dinosaurs are real. It's a
Yeah,
movie.
the moon landing wasn't the movie.
The moon landing.
Hey, Toon,
is a
how you
movie.
doing?
You're watching it.
Hey,
We've got Hillside here, who I guess he didn't listen to anything you said because he's just repeating the same nonsense.
it was
no,
you
you-
know we had a nice talk.
You got Toon in here.
How you
Yeah.
doing, Hillside?
What's up, Mike?
You know what? I was listening to you while driving. Had to pick up my kid. I'm like, hold on a second. He doesn't. He rejected basically all of science, and I'm like, maybe I could explain it to you. What do you think?
Let's give it a
Just-
shot.
Because Craig is like I was. He's all heated up right now, and I'm cold because it's really freaking cold outside here in Minnesota. So science is what it is, and we don't get to pick and choose what it is. It just is what it is. And so I'll present how science is done, and if you think that it makes sense, then you think that science is a good thing. And if you think it doesn't make sense, then maybe you want to find some other way to, discover truths about the universe or knowledge of the universe. So you have to you come up with a guess or a hypothesis, right? For any particular topic you want. Then you figure out what that means. What's the implications of that? So you say, well, I think that donkeys have 5 legs, right? So what would the implications of that be? Well, you could go and count 5 legs on every donkey. So it's a perfectly fine hypothesis because you can go test it. So then you go out there and you find a bunch of donkeys and you count their legs. You say, well, I did not find any donkeys with 5 legs. The hypothesis seems to be wrong, right? So then you're Craig. So then you say, well, it's not supported. I have shown that the hypothesis doesn't have much support. That doesn't mean there can't be a 5-legged donkey somewhere. You did not prove there are no 5-legged donkeys. You did not prove it's impossible. And if any of us have seen any Guinness Book of World Records, we know from people with extra legs and animals with extra legs, there might be a donkey with an extra leg. But we can make a generalization from it. We can say, well, most of the time donkeys have 4 legs and not 5 legs. And sometimes they have 3 legs. One of my dogs has 3 legs instead of 4. So things are sometimes outside of the norm, but there are things that are usually the norm. So it's the logical process of it. It's not something that is super rigid. It is a flexible thing, but it's based on logical thinking, induction and deduction, and some critical thought. And then you throw in some testing and experimentation in there. So can we do something using that process, you think, to find out knowledge about the Earth?
I mean, yeah, I get what you're saying, but like even in the experiments where you're like, so if the Earth was curved, we should only be able to see this far due to this type of refraction. Like, is that what you're saying? Because like to me, you're just saying, this type of refraction is taking place because this is what you're seeing, or you're seeing this because this type of refraction is taking place.
I don't generally say that this type of refraction. I don't generally do that. Refraction is roughly categorized into groupings, but
we should be specific, right?
Exactly, and that's why it's roughly categorized into groupings. It's not rigidly categorized into groupings, so that we can be more specific. So, and when you're doing observations, depending on the amount of accuracy and precision you want, you're going to put more effort into it, into controlling the variables and controlling the things that are messing you up. So if you want to do something where refraction is potentially modifying your view, then, well, if you can somehow analyze the effects of refraction, then you'd include that in. But if the effects of refraction are unknown or super complex, then that really reduces your ability to draw conclusions, or at least strong conclusions from that particular observation. So then you might do something to fix that. You might say, well, let me get away from where there is a high amount of refraction. So if I know, because we've measured previously, that really close to the ground or really close to the surface of water, there's a huge amount of refractions and they're going on, and there's no way we can actually do a sensible and precise analysis of it. So let's get away from the surface of the water where it's super chaotic. Let's go 20 feet up or 100 feet up. And let's do our observation there where the effects of refraction are less and where we can have a better analysis of the refraction so that we can have a better understanding of the actual effects that are going on. So I would avoid doing things where there's this chaotic refraction going on. I'd move up higher. So Craig showed you a picture of something that was 210 meters high. Refraction is still there, but it's just not as strong. and it's much more consistent.
How can I verify that it's not as strong? So to say.
You can look at previous experiments that people have done to quantify the effects of refraction, and if you don't want to trust other people and you insist on doing it yourself, then you could use the same methods that they've done. So one of the methods that people do to quantify refraction is to use two theodolites. Particularly good would be to use theodolites that have automatic. Is that Dave?
This is Dave.
Dave, all right.
Coolest cat.
There's theodolites that have motors in them, and they turn themselves up and down to measure the actual angle. That's what they use when they, a lot of the time, when they measure the effects of refraction. So you could do that yourself. Go rent two theodolites, and you put them far apart from each other at the top of two peaks or something like that, and you point them at each other, and then you have them measure the effects of refraction. Have it run throughout the day, run for several days, run for weeks. People have done this. So you could look at what they've done, or don't trust it and do it yourself. But you can't hand wave dismiss what somebody else did if you're unwilling or just don't want to try it yourself, because if it's been done and repeated multiple times, you get a lot more confidence that it's not just one person who's lying for some reason. So if you publish some paper and it's found out that you're lying, people don't like that.
Now I got you, like with the theodolites, like would they not be considering like spherical refraction? Presupposing, because that's what I took from it.
You can take theodolites and point them at each other and just measure the effects of refraction. You can turn off all of the automated taking into account the radius of the Earth things in it. It's if they're digital, that's an optional thing. Or you can just go get a non-digital theodolite and do it yourself manually. People have done that too before the digital theodolites were around.
Did Jesse do analysis of refraction when he was doing his lake test?
Across the lake, he did not include refraction analysis, but what he did is he chose a day that was overcast, which makes the conditions more consistent, and he moved his so he had a theodolite on both sides, and theodolites have targeting markings on the face that he had. So he which one is it? Not Apple Pie Hill.
Yeah, it's this one down here.
If you just Google Jesse Kozlowski level lake, you'll find it. It'll jump you right to it. So he did not include refraction analysis, but he did it above the surface of the lake. And that's an important thing. He wasn't at 1 foot or 2 foot. He was around 5 or 6 feet above the surface of the lake. Again, reducing the... There you go, 6.14 feet. Yeah. Or no, that's the elevation of target, 6.14. Okay.
Yeah.
That's not the one I'm thinking of, Cooper River Lake. Maybe that is. So, yeah. So he did things to reduce the effects of refraction, choosing an overcast day so the sun isn't shining. When the sun shines on the water, it heats the water, cooling things, heating things inconsistently. You have these different layers of hot and cold. But when it's overcast, the sun isn't doing that because a large portion of the heat from the sun is blocked by the clouds.
So but the theodolite is just measuring the horizontal and vertical angles?
That's all it does is measure angles, yeah.
And it can manipulate the refractive conditions in which it's viewing through?
No, a theodolite cannot do that.
Okay, so if you're looking through a refractive atmosphere, how can you be certain that your measurements are accurate? I'm simply just asking.
And that's the deal with measurement accuracy. So you have a tape measure, and on your tape measure you have markings every 16th of an inch, every 32nd of an inch, right? How do you know when you put that tape measure, you hook it on one end and you're out there 25 feet away from it? How do you know that the tape measure is accurate to 1/32nd of an inch when you're 25 feet away from the end of the tape measure? You're not. There is a margin of error, no matter what. And a better tape measure, which is, if it's a 25-foot tape measure, it's going to need to be better unless it's a cheap one, right? Then maybe it doesn't need to be. But as you get farther away, your possibility for error increases. So then you need better instrumentation. So a good tape measure, one that's a good one for a carpenter, you might pay twice than the one that you get from the hardware store that's just for the hobbyist. But even then, your measurement is no better than the gradations on that instrument. So if it's got a mark every 32nd of an inch, how accurate can you be? Can you be accurate to a 1/1,000,000th of an inch? No, you don't have the markings for it. So when you're measuring across the water and there's refraction in there, but you've done what you can to reduce it, refraction is still there, and it depends on the margin of error that you need.
All measurements have a margin.
You do know from many previous observations that sorry, I lost my train of thought for a second. That refraction causes, unless it's super chaotic, refraction causes distant objects to appear slightly higher. So if something is already too low, and we know that refraction causes something to appear higher, so in reality, it would actually be lower. Well, refraction actually doesn't help flat Earth. In fact, it makes it worse because it raised it already and it's still too low. That's the challenge. For flat Earth, at least.
I got you. I mean, a lot of the refractive conditions that I've seen in these observations is inferior mirages, which is right. It's being miraged below the physical,
Yeah, and so
the object you're viewing.
And like I said, I would say if your observations have any miraging at all, I would skip that observation and seek a different one, because if there's miraging, that typically means that there's reflections, internal reflections between strict boundary layers, where the coefficient of refraction is really high, or the index of refraction is really high between different layers. So that messes up your ability to draw strong conclusions. So just don't look at those observations. Pick a different one where there's no miraging.
And the same, like Pablo's dog, like he's been doing observations all week and all different types of conditions, but nothing is ever lifted above the physical. Like all of the refraction conditions are taking place below, the actual oil rig. So, and I get Craig's example with the cold gas on on the barrel and everything.
Yeah, that's just showing that the Snell's law, the application of Snell's law, matches reality, matches observation. So that's the scientific process again, right? We have a model, a hypothesis. We calculate the effects of it, or not the effects, the consequences of that. We say, well, if Snell's law is right and the index of refraction gradient is this, then we should be able to see the light bending in such a manner. So then you put that cold stuff on the barrel, and it confirms the hypothesis. So the hypothesis seems correct.
I'm looking at Snell's law right now, and it's talking about conditions in which light passes through two different mediums.
Yes.
Okay, but like when we're making these observations over the water, that's just one medium, right?
Yeah. So you're looking at the simplified version of Snell's law. Now, you did not go to university and take calculus, right?
No.
Okay. So the simplified version of Snell's law that you're looking at doesn't deal with the things that you would need to deal with in order to get a gradient within a medium. Right? You'd need a partial differential equation, most likely, which I would guess you haven't ever done a partial differential equation.
No, I mean I'm willing to look into it for sure.
So I would recommend then taking a calculus class at a local community college.
Okay, would any of this calculus involve the radius?
No, it's just raw math. Calculus.
Or no spherical, geometry or trigonometry.
Well, if you did not do a lot of math in high school, my guess is that a calculus class might have some prerequisites that you need to cover first. So you might need to start with some previous non-calculus math. Those at the typically at the like the 90 or 100 level at university, you would potentially get some spherical math in there.
Okay, yeah, I mean, but you get my point. Like, doing the math within the the more complicated version of Snell's law would require some type of presupposition of the spherical nature in which we're trying. Like, am I wrong? Like,
not at all.
Okay,
not at all.
Okay,
Absolutely not.
That was my question. But whenever you said yes, there's some spherical trigonometry involved.
Oh,
that leads
I was
me
just
to
talking.
believe then yes.
No, what I wasn't talking about Snell's law. I was talking about the mathematical subsection, the subsection of math that is doing trigonometry on the surface of a sphere. I thought you were talking about that, but because that's another, right? That there's Euclidean geometry, which is x, y, z. And then there's things like polar geometry. Did you ever do polar geometry?
No, I was looking into it earlier today.
Polar geometry?
A lot of time. No. Well, just the different, spherical geometry and stuff like that. So.
Yeah. So polar coordinate systems is another coordinate system that's actually just a two-dimensional coordinate system. But instead of x, y, you have a distance from the center and an angle. It's typically r and theta. And then there's transformations you can do between those coordinate systems. Same thing with a three-dimensional Cartesian coordinate system and a spherical coordinate system. There's a couple different ways to do spherical coordinate systems. These are things you would cover in a.
Yeah, I've never seen polar geometry. What, there's 3 different types: Euclidean, spherical, and hyperbolic.
Well, there's probably many more than that. Polar coordinate systems are often covered in high school. I covered it in high school, but different schools may have different things they cover. So anyway, not to get off on that, Snell's law, when looking at a gradient within one medium, you need to do calculus. So the basic version of Snell's law won't cut it.
I don't know, man. I'm not buying it, Mike. I mean, I have to know all of this crazy geometry to understand what I'm seeing with my eyes under different atmospheric conditions on different days.
And like I said,
and none of it lines up with the geometric map of the sphere that we're being presented with.
It actually all does, but you did not do the math, and I understand that it's not the type of math that you've done before, so you're not going to be doing it.
Can you present it to the audience? I mean, you turn over a lot of flat earthers. I mean,
I showed it to you last time. I showed you the application using ray tracing of the claimed black swan, right? Where the model predicted, the globe model predicted the curvy.
That just doesn't prove it, man.
It doesn't. No.
Hold on. Wait. Conditions,
hold on.
It's not hidden.
Don't say I gotta back you up here. You said that just doesn't prove it, and I gotta remind you, science is not about proof. Pseudoscience is who wants proof. But
okay, well, that's not sufficient evidence. Then I mean,
you're
pretty much just saying, don't believe your eyes. This mathematical equation is what's actually happening. Well, you can understand how that doesn't sit well with a lot of people.
In science, the way to describe your proof is with math. So math is very important. Using an equation, like if we're talking about Snell's law or Newton's law of universal gravitational attraction, these are equations which mathematically describe the universe, and that is the way in science that you prove your ideas, is by backing it up with maths that can, you can use to make predictive models. Science itself doesn't prove, but you can use the data you get and then try and prove that by demonstrating it can hold up to being a scientific model.
Well, if you guys will hold it to me, I'll use my carpenter brain, what brain I got. All right, I'll take it easy. I'll look into the math and I'll get back with you. I mean, I just don't know it off the top of my head. So
can I suggest this then? That don't look at the observations where the conditions are super chaotic.
Yeah.
Focus on the conditions focus on the observations where the conditions are consistent and very boring.
Like this one.
There you go. See, you see how consistent that is? There isn't this waviness.
And when I have Mike, there's a ton of them where you don't see any distortion in the video, hardly any. Like it's a little blurry because they're zoomed in, right? They're trying to see super far.
Yeah.
But you can still see the physical oil rig, like with little to no distortion. And then when it's heavy refraction and distortion, it's inferior miraging below it on the water.
Yeah.
So
unless
that's what I'm seeing.
I cannot do the math for the inferior mirages and all that. I'm not interested in doing that math. It's way too much. So I would never use that as an observation. So if you can't do that, then and I can't do that, and Craig, you're not doing that. Let's not look at those observations, because unless somebody can do it and is willing to do it, then you cannot draw strong conclusions from them.
I don't know, man.
Right,
Trust
so,
my eyes.
As a carpenter, all right, let me ask you, can you have level on a ball?
I mean, you can probably balance a level on a ball. Yeah, I'm sure it's possible. I've never done it.
You're right.
There you go. Hey.
Would you say that is level?
No, it's pitched a little bit.
I mean,
it is.
It's within the lines. I'll give you that.
Yeah. That's definitely being
We
level.
accept that down here in Georgia.
Close enough. No offense, but I'm not hiring you.
No worries, man.
I've been to Georgia. It's all good there.
All right. I think it's about time to read some super chats. Do you want to hang around and see if there's any questions for you?
I'm going to head out. It's been good talking to you, Hillside. Thanks, Craig.
Catch you there.
Take it easy.
All right.
All right. For $2, £2 for €2. Thank you. Wind Caller became a new member. Thank you very much. Members only stream towards the end of the month, where you can win a limited edition Team FTFE t-shirt, which has been designed by one of the fans, and it is incredible. Only 10 of them exist, and you could get one. Scotty Mac, $20 with lots of Earth globes. Thank you very much. Technomancer Magus for $10 says, sorry about being grumpy in chat last debate. I get what you're doing, but I was getting so frustrated with the Flerf going unchallenged. That's not me. Keep doing your good work, you rock. I think I challenged him, Bro Sanchez, and everything he said. But I didn't want him to be scared off having another debate, so I was being a little more reserved than normal. William Foley, $5, claims to be in construction, doesn't know how a water level works. Based on what just happened with the ball and level there, I'm going to give him at least he understands that it can be level on a ball. So there's that. Alison, $5. Hillside, why is all navigation based on a globe, and why is there no flat earth based navigational techniques?
Well, everything that I've looked into, they pretty much use the flat map, and then they add an extra axis to it to make it into a globe. So I mean, all navigation is done on the Gleason's map. The pilots fly by it.
No, they don't. Pilots do not fly by the AE map.
Hey, look, man, everything that I've looked into, like you're saying this now, and I get it because you have to hold a certain position, but I can only go off my experience and what I've looked into. So
let's just sailors at sea using a sextant, right? A sextant measures the angular elevation or angular separation between two things. Main use for it is for measuring the angular elevation of a star above the horizon, right? But the entire function...
flat horizon, though. It has to be a flat horizon.
That's not so important. It's the fact that the angular elevation
it's not
of
important.
the star
Come on, bro.
is based on the fact that light is coming in parallel. So if you were at Polaris and you were looking at the light coming from Polaris, it would be 90 degrees straight up. For every 60 nautical miles or 69.1 statute miles, Polaris decreases in the sky by 1 degree. And that doesn't make sense if the Earth is flat, because it would get greater and greater and greater. but it matches the fact that the Earth is a sphere. And the way a sextant works for you to calculate your distance to the GP of a star relies on the Earth being a sphere. So, I mean...
Well, when we're talking about celestial bodies, like I said earlier, I think me and you can't go all the way up there. So we would have to speculate on what the nature of the sky is and what it is.
I go to space all the time.
I hear you, dude.
Right. All pilots use the Haberstein formula to calculate their flight routes. That requires the Earth to be a sphere. Eric via Thurler92 499 says, could he be a Poe or could he be a genuine Flerf? He's a baby Flerf. Who's your Papa Flerf? It's Dirth, isn't it?
Papa Smurf?
Papa Flerf.
Oh, Papa Flerf?
Yeah, it's Dirth.
I don't think I have one. Am I supposed to have one?
Yeah, well, I think it's Dirth. Your arguments are quite a lot Dirth with a bit of Nathan Oakley thrown in.
I mean, I've watched a lot of videos. I mean, the Plain Truth, the Banjo guy. I mean, there's a ton of them. I wouldn't say I specifically like one.
Do you know Nathan Oakley?
It's just information. Yeah, I know Nathan Oakley.
Vile human, isn't he?
Y'all best friends, ain't you? Y'all probably hang out outside of these debates, don't you?
Nah, man, he's scared to talk to me. It's hilarious. Cillin Hollard for €5. Hill, have you seen the wind? No, you only see the effects of the wind. You can't see the wind or the geometric horizon, but both are real. Yeah, true.
Yeah, but I mean, I can see the wind blowing if there's like smoke or something in the air, right? I guess that would be the effects of wind on the smoke, but still, you can see it moving through the air. So.
Well, you can't see the wind. You can see the effect of the wind, like in smoke and stuff.
Did you like that
Light
one?
says, how can you use sextant on the globe? Doesn't all sextant require a 180-degree baseline? That is called a tangent. Your baseline is a tangent to your local point. That's it. Literally, sextants don't work on the flat Earth. Okay. Alison for $5 says, have you ever heard of glasses? These things that a couple people use to see clearly and require intimate knowledge of how refraction works. Yeah. Yeah, we know how refraction works. That's how we make things like this for me to see. Oh, God, everything's really blurry. I should not take those off.
Well, your glasses aren't 12 miles away. So. No,
but they work on refraction. And if we didn't understand refraction, we couldn't really make the glasses. Onoi Cyan for $5 says, the zoom argument is dumber than the Conman MC Toon exposed. How do people not know how opaque objects and hills work? Beyond me. Holy Smalls for $2 says, globe proof. We don't see far enough. Yeah. It's if you say the flat Earth proof is that you see too far, well, I say the proof that we're on a globe is the fact that we don't see far enough. We'd be able to see way further if the Earth was flat.
Yeah, but you claim, like, with all due respect, Craig, like, you guys claim a geometrical circumference. So
yeah, it's been measured, yeah.
You could do basic math, right?
Yeah.
1.225 times the square root of the observer's
that doesn't take into account
height
refraction, what you're saying.
Okay, so. But like, here we go back to refraction, man. Like, you're
well, you
wanting
can't
to be
ignore
one
whenever
thing,
you're talking about what you can physically
but I
see.
can't.
From
But I
the
can't
surface of the
observe
Earth,
what
you
you're
can't
saying is
ignore
happening.
refraction.
In
But
any type
there
of conditions,
there
heavy
is other
refraction,
ways-
no refraction, very
There's
minimal
other ways
refraction.
to measure the circumference of the Earth that take
No
that
matter
into
what-
account.
Right, Craig, no matter what conditions there are, right, with little distortion, we can still see too far. And the change and variation
Yeah,
of the
because
distances
refraction's
that we can
always
see
there.
are not nowhere near enough to validate.
Well,
your
what's your
model.
evidence for that? Do you have an analysis to say it's not enough to validate it?
Dude, I'll go to Kennestone and shoot that for you, bro, and I'll send it to you, okay?
Yeah, okay, but you
But
still need
there's
to
tons
give
of
me an
other
analysis.
ones. If you just
still
want
need to
the
give me
one
an
that I
analysis
have.
of the refraction and why it wouldn't be possible on the globe like we say it is. Because
you can't
all the
verify
refraction we
that-
see is what we expect, and yes, it's been verified.
Yeah, you expect that because you're laying claim to a certain model. So
Well, yeah, because again, that's how you
it's
have
not
to do things in
proving it.
science.
You're just saying this would happen because this is where we live.
Yeah, again,
and
that's
this
how
is
you
why
do
it's
an
happening.
experiment in science, is by making a prediction and testing it. That's what science does.
I got you,
Cody
but it
Smalls
doesn't prove
says
it.
for
so-
$5, you have my permission to use me as I am ordained. If God is only powerful enough to make the flat earth, he is a puny God, and my God is stronger. Well, there you go. Cody Smalls says that the flat earth God is puny, and I absolutely agree. Puny God. The Sun Express for $5 says, hey Flerf, I'm in a tall building in Chicago right now looking due north. Why can't I see the stars above Australia?
Han, so I got one question though. You think that nothing exploded and created everything?
That's not what the Big
Just
Bang
kind
says.
of off
no.
topic.
No, that's not what the Big
Say
Bang
what?
says. That's not what the Big Bang says.
I never said the Big Bang. I'm just saying how it all started, right?
Yeah,
I'm not saying it's a
so
Big Bang. I'm
there's
just saying.
never a case of nothing exploded. That's not what we say. All the energy.
Well, you
that
have to have
exists-
some type of theory.
Yeah. The Big Bang Theory states that all of the energy that exists in the universe right now existed at the beginning of time, but in one infinitesimally small singularity, which for some reason, we don't know why, expanded rapidly. That's what the Big Bang is. So that's what we say, because we can look at the universe and see that it's expanding and mathematically model it back.
Okay, so from my point of view, that's, just a religious viewpoint, bro. Like you believe that.
Well, there's evidence
so
for it, so it's not religious at all.
What's singularity? So it was never nothing. It was just always a singularity. Where did the singularity
There was never
come
nothing.
from?
That's not what we claim.
So a singularity exploded and created everything.
No, it wasn't really an explosion. It was an expansion.
What caused it to expand?
We don't, like I said, we've no idea.
Got it.
That would be
What was
outside
the
of the
question
universe,
about
and
the
we've no idea.
stars? What?
He said, right, I'm in a tall building in Chicago right now looking due north. Why can't I see the stars above Australia?
I mean, you can't see forever. I mean, you were looking through atmosphere with refraction, right?
Well, stars are a long way away,
Okay,
and
well-
we can see them.
Okay. Okay, well, you're presupposing the nature of the sky yet again.
Well, no,
We don't know what the
even
sky-
if the
we don't
Earth is
know-
flat, the stars are a long way away.
Okay, and just how, like, I told you about converging lines on that brick wall, the ones above you eventually will go downwards, even though you know they're going parallel from
Yeah,
the
a
point of view
perspective
of that
says that the
specific
stars
line.
would
So
never
the stars-
disappear.
Right, so the stars that are further away from you will appear lower in the sky and eventually merge with the horizon, and
Yeah, but
you
the
can't
stars
resolve
are
it.
so far away that
it's
would never
pretty
happen.
simple. I mean, if you think about it.
Yeah, but the stars are so far away, the angular resolution and perspective says that would never happen, even if the Earth was flat. So, it's again, it's special pleading, some kind of special physics that applies only to the specific flat Earth. It's incredible. Pat G for $5 says, "Dear Flerfs, the government can be full of scumbags and the Earth can be round. They can coexist." No, seriously, they can, you fucking idiot. So it doesn't matter if there's people in the government that lie. That's what politicians do. It's kind of their wheelhouse. Doesn't change.
Right,
the
so
fact
if
that
like
the
me
Earth
and
is
you were
round.
business partners, and I just
I
lied
wouldn't
to
go
you
into
a
business
couple,
with a
couple
carpenter. It
times
doesn't
during
use
the
tools.
week. The rest of the week, you would just trust me, right? Because that's pretty much what you're doing.
I wouldn't trust someone who claims to be a carpenter but thinks they can measure with their eyes. No.
Okay, so but your government just lies to you like Monday through Wednesday, but you believe them Thursday through Sunday.
Well, things that they lie about aren't really relevant to me, and I don't know what they lie about, and if it's important. They lie about certain policies and the way they're going to run the government, but they certainly don't lie about the shape of the Earth, because that's not something you can hide. Johnny Own H Music, the volcano is a paid actor. Everyone knows that. Yeah, man. We saw the volcano explode from space. It maps out a globe.
It's a direct energy weapon, guys. Look it up.
A volcano is a direct energy. Fuck me. No, Jahalite, a tangent line does not... Oh my god, Jahalite says a tangent line requires an R value. No, it doesn't. A tangent does not require an R value at all. In fact, I mean, that's one of the dumbest... A tangent is simply a line intersecting with a sphere. Does not require a tangent. Fucking hell. Wow, that's extra dumb. James Smith, $4.99 says, refer to him as Professor Dave's channel. Refer him to Professor Dave's channel. He demonstrates that one can tell the Earth is round without doing any science. Yeah, have you seen Professor Dave?
Yeah, I kind of tuned him out when he started referring to like the Flat Earth Society, and like I get it because that's where we all first kind of fall into because of the algorithms, but then you start hearing alternative viewpoints that just, man, they just hit home with, you know,
Yeah,
what we experience every day. So
yeah, when he did his first video, yeah, he kind of went with the Flat Earth Society stuff, but then when Globebusters tried to debunk him, he switched to actually talking about the modern Flat Earth stuff. But then he did a final video, which was like, it was debunking Flat Earth without any science. And I would suggest you watch that.
I did watch it.
Right, well that one's pretty hard to deny. Channel Right for £5 says, our globe and our universe are beautiful. It contains all the magic and drama we need. Why do people believe in silly made-up things in 2022? Honestly, people are flat earthers because they want to be special. That's what it is. And I'm talking to you there, Hillside. For some reason, you've fallen into flat earth because it's given you a belief that makes you feel special. You know something that all the other people in the world don't. They're too dumb to understand, but you are one of the special few that understand it. And that makes flat earth very appealing to you for some reason. And that's something you need to shake.
I never said that.
No, but that's
I
exactly
never said
what
it makes me feel special. I don't like being lied to. I think that's how we all feel.
But no.
So
but you're not being lied to.
If you tell me that I'm spinning 1,000 miles an hour, right, and I walk outside,
no one's spinning 1,000 miles an hour. You don't spin in miles per hour.
Look, we all know what 15 degrees per hour shift translates to. Okay,
at the equator only, it equates to a tangential velocity of 1,048 miles an hour.
No,
how fast is that?
How fast is that
tangential? How fast is that tangential velocity at the poles?
Okay, look. So you tell me how a plane, right, can leave the North Pole, north-south, land on a north-south runway on the equator. Where does it gain that extra, momentum from, right? It's conserving momentum.
The fact that it's flying through the atmosphere and has engines that give it thrust and power.
Okay, but it's not attached to the ground, right? So is that
but the atmosphere.
What's going on?
The atmosphere rotates with the ground.
Neil deGrasse Tyson says the Earth.
The atmosphere rotates with the ground, and the plane uses the atmosphere for thrust and lift.
So why doesn't the atmosphere spin way faster and higher elevations?
It spins slightly slower, actually. A slight drag behind.
That's completely opposite of what should be happening.
No, it's exactly what physics says it should happen. Just because you don't understand physics doesn't mean that's how physics works.
Oh, yeah, you're just saying I don't understand.
Scotty Mac
it.
became a new member. Welcome to Ultimate Forum. Ultimate Forum. Fuck me. Thank you very much, dude. Scotty Mac for $20 says this is so hard to watch. You are right. It sometimes is. Dude, Ultimate Forum. Thank you. Pat G for $20 says Tonga literally blew up the flat Earth. Flerf. Nuh-uh. Yeah, dude, that Tonga volcano is destroying flat Earth. Seriously. Throw the Dwarf of the House of Torg for $5 Australian says, there is no point giving your soldiers the wrong maps. What possible reason could you have? Yeah, military definitely know the Earth isn't flat. Syed Ahmed, $199. Nailed it, FTFE. Hillside is purposely ignorant. I don't really care if I offend you, but it's a fact that you are ignorant. And I'm not saying that in a nasty way, but you don't understand physics. You are ignorant of basic physics. And that is a big problem in this discussion.
You failed to change my mind this entire debate. You've presented
even though all the evidence I presented,
whether this is just a show for you, or is it actually to inform people? You've done absolutely nothing. You're just saying that I'm dumb. I don't understand math. I don't understand physics.
But
cool, man.
I have shown plenty of evidence that debunks you, and you went nuh-uh to the entire thing. It's not my fault that you don't understand.
It's not sufficient evidence.
Well, most people with a brain would disagree. And I must congratulate you to get to adulthood without having functioning grey matter. That is a very, very big accomplishment. Draco Fire, 200 Japanese yen. We might have a new record for most negative IQ. And then another 200 yen. I'm going to have to disagree, bro. Yeah. Marty Mad Scientist, who's been a member for 16 months, says, this is why we build with dimensional lumber. Thank you very much. Draco Fire for 500 Japanese yen. Not only is the camera below the ground
that was a low blow.
Yeah. Not only is the camera below the ground here, but the sun is also going behind a mountain. Can you get more moronic? Yeah. In that Durf video you showed, Durf literally showed that the sun gets obscured by a physical item. Good fucking job. Can you send me the link to that video, please?
It's
That's
the atmospheric deck of opacity. Like over long distances, the
No.
atmosphere
He
becomes...
literally has the sun go behind a physical thing.
Right. I mean, that's just representing like, you know, a tree line,
The
or like a
horizon.
skyline of. Well, I mean, it's just being eclipsed by a physical object. So
It matches exactly the video you were showed by MC Toon when you debated him.
so the table is curved. Like, chill, bro. Like, you understand it. You're
Half
just
of
trolling, man.
more than half of that camera was it was like looking like this. This is not how you look at things.
Okay, so is a lens completely flat? Like, no, the camera is, you know, what, 6-7 inches? So he's just trying to get the lens portion that's filming to terrestrial point
again,
of view.
you
in
don't
that
have
experiment.
half of your eyes underground when you look at shit. Fuck me. Dax
Okay,
Marshall
when you
for
don't
$5
have-
says, I would totally tune into live stream smoke
Bro.
sessions with Craig, even if it was just once a week. I would love to smoke with the legend himself. If they allowed smoking weed on YouTube, then I would do a smoking weed channel, because you all know I'm a massive weed advocate. It's it's a magic plant. It's the only thing that allows me to control my pain. And
I
if
think
I
that's the
was in
one thing we
charge,
can agree on.
It would be not only legal but mandatory, I think. Not before you're 25 though. That's the thing. Circle back 96 has been a member for 10 months. Says shit. Kitchen sink debunks the globe, bro. Lol. Oh, that Durf video is fucking hilarious. Facty for $2.79 Canadian says he's a perfect top left Hillside. Yeah, top left. You might be an early nominee for the Hillside. Might be an early nominee for the top left awards. We'll see. Currently, I'm thinking about Mitchell from Australia, but you've had some two good showings here, Hillside. Jake the Surgeon for $10 says, if you took a Tatawa and have a knowledge of taxonomy, paleontology, and anatomy, you will think it's a lizard when it's not. You can't trust only your eyes a lot of the time. I couldn't pronounce half those words, but thank you very much. JRock69 for $6.99 Canadian says, I'm so glad this didn't get to Coriolis. I really can't listen to the Coriolis nutters as a long-range rifle shooter. Smoke. Cheers from Canada, Craig. Yes. What do you think of Coriolis?
I mean, you tell me, does the Earth spin under footballs?
That's not what the
'Cause
Coriolis
that's
is. No, you just... Well done. You did exactly what I expected you to, and instantly strawman Coriolis and what Neil deGrasse Tyson said, because he didn't say the Earth spins under footballs.
Okay, well then enlighten me what your position is then, so that I can hear it. So.
Coriolis is simply the conservation of momentum, the difference in something having a tangential velocity at one point to being above a point with a different tangential velocity and maintaining its momentum between those 2 points.
Like when the plane leaves the North Pole and
Planes
tries to land
have
on an equator.
engines which create a force that can counter the very small Coriolis force.
Gotcha.
Yeah. Plane's big engine go broom. Okay. Room 237 for
Outrun the
$5
Earth.
says his
Boom.
mum brought in a Fisher Price tool set and he thinks he's a carpenter. JRock69 for $2.79 Canadian. Glad Toon came to slow the crazy down. Hillside is gone. Yeah, gotta love Toon. If you're not subscribed to MC Toon, then you should do that. House of Fire $4.99 says, good to see Toon back with his almost unshakable disposition. I thought he was getting cranky lately, but he diffused this one momentarily. Yeah, Toon was on fire the other day, mostly because of the Gregory Garrett thing, which is fucking hilarious. It's riled him up a bit, and I love seeing the angry Toon. He swore again
Well, poor
twice
Mike
the
just
other
wants
day.
a citation, man. I get it.
Draco Paul, $10 Canadian, says, Hillside, you saw the model assuming the sun is 3,000 miles up. As the sun moves from morning to night, why isn't it shrinking to 1/7 of its noon overhead size? That's what should happen in reality.
See, would you agree that I could just make a model like that and just make it do whatever the hell I want it to do?
Not
And
if
just
it's
be like,
based
hey, why
in...
doesn't this happen?
Well, that model that I made is based in perspective and, factual information between data points. So
Without
if you
all
can,
of the
if you can make
variables
something that
that
works
take place
according
in
to the rules of
reality.
reality, that does what you say, then I would love to see it. But you can't, and that's why Flat Earth doesn't have a model. Jake the
That
Surgeon
does
for
nothing
$5
for what
says...
you showed me.
Yeah, it matches what the Flat Earth say. Jake the Surgeon for $5 says, reject Flat Earth, embrace big anime mummy milkers. If you say so, no worries. Fuck YouTube $5 says, Halloween is over, Hillside, put away the straw man. Yeah. Again, your ignorance of physics means that you build strawmans to argue against, which is the issue. Thank you for the super chats, guys. The Sun Express for $5 says, Dear Flerf, driving down the highway at 60 miles an hour with the windows open and the AC on blast, how fast is the air moving inside the car?
Yeah, I do that all the time.
Okay, never mind the question. Pat G became a new member. Welcome to Destroyers. Thank you. Azure Australians for $2 Australian says, Flat Earther, Moronicus Expeditatius. I know that's a Harry Potter spell, possibly, or a new name for Flat Earthers, but thank you. Wind Cooler, $20 Canadian. I decided to make an animation that demonstrates how a plane works on the globe. Please feel free to use it if you want to, no credit needed. And that goes for anyone who wants to use it. Please email me at fighttheflatearth@gmail.com. Thank you very much. Carl N.R. Christiansen for $100 Donkey Kong dollars says, Neil deGrasse Tyson also says the Earth is not flat. Yeah. Neil doesn't think the Earth's flat.
He said it's pretty flat, dude.
Yeah, he said it looks flat, but he very clearly thinks the Earth is an oblate spheroid.
Yeah, there's a geometric horizon, you just can't see it. Dude, I get it, bro.
Yeah, you'd want to repeat facts over and over and still not understand them. That's cool, no worries. Last one, Draco Fire, 200 Japanese yen. You can't just pull a model out of nowhere. Lol. No, you can't. You're right. Thank you very much for the super chats, guys. You know the best way to support the channel if you can't help me financially is to share what I do on Facebook and Twitter. So I really do appreciate everything you guys do. Right, Hillside, I'm going to pack up for tonight. You got any final thoughts?
No, man. Appreciate you having me on, man. Take it easy.
Thank you very much. Speak to you later. All the nutter. Gary Webenenga says, Coriolis effect would be caused by Earth spin. Of course, there is no Earth spin, and there is no Coriolis affect, and pilots don't do anything for it. No, well, pilots have engines, that power their big-ass planes. But as for Earth spinning...
If the Earth is spinning at one rotation every 24 hours, that means that every hour it has to turn 15 degrees. And if the gyroscope is mounted anywhere on Earth, it's going to drift. In today's 21st century navigation systems, they're using what's called a ring laser gyroscope. It is extremely precise. If we could simply get one of these ring laser gyroscopes, we would be able to prove once and for all that there is no rotation to the Earth. One of the people in the community actually purchased one for $20,000. But what we found is when we turned on that gyroscope, we found that we were picking up a
what kind of drift, Bob?
A 15 degree per hour drift.
Thanks very much, Bob. I do appreciate it. Thank you, Bob. Thank you. Yeah, thank you very much, Robert. Says Laurentiu Dinka. I'm sorry if I've ruined your name there. I'm sorry. Jake the Surgeon for $5 says, Hillside, if I show a skeleton of a lion and a tiger, could you tell the difference with just your eyes? Probably not. No. I wouldn't know how to differentiate the skeleton zero. But that's going to be it for tonight, guys. Hopefully a new episode of Flerfs Idiots coming out this week. Another debate on Saturday, which will be moderated by Ranty. And it's going to be round 2 with Gleason. So please bring facepalm protection. Thank you, MC Toon, for coming on. Thank you, everyone, for the massive support, as always. I really appreciate it. You are all the best. Remember, stupidity is not a right. Fight the flat earth. Look at the animated grass and everything. This one took so long to render. Good night all. Hope you had a good time. got to be up early tomorrow to get my car in for its MOT, so... Who's that gorgeous person? I accidentally made the Earth rotate a bit fast, same with the moon and sun on the flat Earth. Please share the stream, guys, it really helps. If you share what I do on Facebook and Twitter, it really, really, really does help the channel and bump up views. Remember, stupidity is not a right. Fight the flat Earth. You better be dancing, guys.